Right. So section 9, welding procedure and welder qualifications. Generally, for welder qualification, PQR, WPS, we have to follow ASME section 9. And if there are any additional requirement, 650 also you have to follow. Who is responsible for the procedure qualification and welder qualification is, it is the manufacturer, not the purchaser. Okay, manufacturer who is employing the welder, he only responsible for the qualifying procedures. Same if you go to the 653, after that we will go 653. Yeah, he also joined. Good. Okay, if you go to the 653, it will be the repair organization. 653 we are doing only repair. So there is no manufacturer. It will be a repair organization. So for storage tank and attachment to storage tank procedures, we have to qualify according to ASME section 9. But other handles, structure items, you can use AWSD 1.1 also. So please highlight this one. The first one, the erection manufacturer and the fabrication manufacturer, if other than the erection manufacturer, shall prepare welding procedure specification and shall perform test documents by procedure qualification to support specification as required by section 9 of the ASME code and any additional provisions of the standard. So if they ask exam question, as per which standard we have to qualify procedures, section 9 and 650. It is not only section 9. We have to follow any additional requirements of the 650 also, because 650 have some additional requirements. Now, this one also important. Welding procedure for ladder and platform assemblies, handles, stairways, and other miscellaneous assemblies, but not their attachment to the tank, shall comply with the AWSD 1.1, AWSD 1.6, section 9 of the ASME, including the use of standards WPS. That is important. Suppose it is not attached with the tank, only the handle. Okay, or we can have platforms which are not directly attached to the tank. You can use D1.1 or D1.6 also. Now, see, ASME section 9, there is a P number and there is a group number. So, what is the P number is? It is a grouping of base metal. On what basis the ASME section 9 P number is? Chemical composition, weldability, mechanical properties. And the group number within the P number, we have, for example, P number 1. We have 3 group numbers, 1, 2, 3. When the group, generally group numbers are not important. When you want to do impact test, then group number also become essential variable. Section 9 next week we will see. So when impact test is not required, no need to look for group number. Group number is no need to mention at all. But when impact test is the requirement, group number become essential variable. So you cannot change the group number also. If no impact test, you can change the group number. Now, you see in the chapter 4 of the ASME 650, we have 6 groups, 1, 2, 3, 4, 5, 6. That group, ASME section 9 group, there is no relation. That is different, this is different. Okay. Now, for example, what is our common tank material? SCA 516 grade 60, 70, they are covered in ASME section 9. You can go and check P number and group number, everything. But suppose any material in 650 is not covered in section 9, and you don't know what is the P number, what is the group number, then how to find out the P number, group number? Suppose it is not listed in ASME section 9. So code says all the material given in chapter 4 here, all P number 1. Okay, don't worry about the other P number because they all are carbon steel only. But how the group number based on the tensile strength of the material. If the tensile strength is 70 less, take it as a group number 1. That is ASME group number. Okay, so because impact test group number become essential. 70 to 80, take it as a ASME group number 2. More than 80, take it as a ASME group number 3. Okay, this is important. See, material specification listed in section 4 of the standard but not included in table QW 422 of section 9 shall be considered P number 1. If it is here but not in section 9, take it as a P number 1 because all are carbon. With the group number assigned as follows according to the minimum tensile strength. Less than 70 KSI, we will take it as a group 1. Equal or greater than 70 KSI but less than 80, group 2. That is open book question. Equal or greater than 80 KSI, we will take group 3. And separate welding procedure and performance qualification shall be conducted for A841M, A841 material. Suppose you want to use A841, there is no P number group. We have to make PQR only in that material. It is not allowed to do the other. Is it clear? Now, sometimes what will happen? ஆமா அதுல இல்ல. So you have to இதுல 841 you have to make PQR only in 841. Sometimes what will happen? The storage tank, they will make a fit up first. Okay, first they will make a joints fit up. For example, shell butt joints. Welder, they may not be available. Welder is not available, so they think welder we will do after 1 week. So within 1 week, what will happen? The edge preparation will be corroded. To avoid that, generally what we will do in construction now they are using masking tape. But there is one more option is there. You can use a painting also. There is a protective paints are available. India, we were using long back. I am selling some 30 years back in piping construction. They used a aluminum coated, aluminum paint like this. No need to remove the paint during welding. It will automatically weld as come as a slag. With the paint, you can weld a thin coating, protective coating. You can do it. In the piping use பண்றாங்க. என்ன பாய்லர்ல ஒர்க் பண்ணிருந்தீங்கன்னா யூஸ் பண்றாங்க. பாய்லர் சைடு. A thin protective coating they will apply to look like aluminum color. Welder, when weld it, just weld it with that paint, the paint will come as a slag. Now, what 650 says, if you are going for a protective coating, then during PQR also, you have to apply protective coating and to make, because you have to check whether it affects the mechanical properties or not. The purpose of PQR is to check the mechanical properties. So you have to confirm whether the protective coating affects mechanical properties. So highlight this one. If a protective coating has been applied to surfaces to be welded, the coating shall be included as an essential variable of the welding procedure specification. Procedure qualification test shall be required for each coating bronze formulation and for maximum thickness of the coating to be applied. So you have to consider that also essential mandate. You have to apply during the PQR test. Now, impact test. You see chapter 4, impact values. There was a table. You can see the table. Group 1, 2, 3, 30 foot-pounds. Group 4 to 6. But that is for the base metal. That is for the plate. But when you are making a weld, how the weld value you have to take. Okay, this is the next one. For all material to be used as a design temperature below 50 degrees Fahrenheit, the qualification of the welding procedure for vertical joints shall include impact test, irrespective of materials. See, generally, chapter 4, how we will find out? We have to see the group number. Then we have to use the equation. If you want to use below this, then impact test is required. If you want to above this, impact test not. That is separate. That is for material. When you are making a PQR, first condition is if you are going to use below 50 degrees Fahrenheit, vertical joint PQR impact test is mandatory. Whatever the thickness, whatever the group number. என்ன group use பண்ணாலும் என்ன thickness இருந்தாலும் storage tank temperature is going to below 50, all vertical joints impact test is mandatory. Okay, this is for the welding. The qualification of welding procedure for vertical shall include impact test of the weld metal. If vertical joints to be made by a machine automatic, impact test of the heat of zones also, that is open to question. When the design metal temperature is below 20 degrees Fahrenheit, impact test of the weld metal shall be made for all procedure used in the welding. Suppose if it is less than 20 degrees Fahrenheit, design temperature, all procedure, whether it is a horizontal weld or vertical weld, we have to do impact test. It is only for procedure impact test. Now, what value you have to use it? Impact test shall know minimum values for acceptance in 4.2.3 and following. For P number group 1, we have to take PQR. This value you have to use 15 foot-pounds average of 3 for this one. P number group. P number 1 group 2, 20 foot-pounds. P number group 3, 25 foot-pounds. We have to take. We will not follow that values. For procedure, we have to follow here PQR. For plates thicker than 40 mm, 1.5 inch, this value shall be increased by 5 foot-pounds every half an inch. Over interpolation is for interpolation averaging we can do. For example, if we take P1 group 1, what is the average required? 15 foot-pounds. This is applicable only when the thickness is 1.5 inch or less. Suppose your thickness is 2 inch. So every half an inch, how much you have to increase? 5. So 15 plus 5, that should be 20 foot-pounds value you have to get. That is the meaning of this. Exam point of view, this is not important. Exam they never ask. Leave it. 20. Okay. Then highlight this one 9.3A 933. Each welder or welding operator shall be assigned an identified number, letter, or symbol by the fabrication or erection manufacturer. That is important. So every welder you should give an identification number. Now highlight the B. The fabrication or erection manufacturer shall maintain a record of welders or welding operators employed that shows the data and the results of the test for each welder welding operator and identify mark assigned to each welder welding operator. The record shall be certified by the fabrication or erection manufacturer, shall be accessible to the inspector. So you have to maintain a traceability, which joint is welded by which welder. Then where we will write a welder number in the tank. Tankla vandu every 3 feet it should be hard stamp. Suppose hard stamping is not allowed due to some service condition, you can write with the paint also. Even painting is not allowed. You are going to paint it now, you have to mention on the drawing. Only the flange neck wells, this one nozzle neck to flange wells does not require welder identification. In the previous revision, even roof plate does not require welder identification. There was a condition, now it is removed. So roof plates now requires welder identification. Okay. The welder or welding operator's identification mark shall be stamped either by hand or machine on all tanks. The mark shall be adjacent to at intervals not more than 3 feet along the following wells, liquid containing including all opening. So every 3 feet you have to stamp it. The 3 feet is a closed book question. Flange to nozzle neck wells do not require welded identification. In the previous revision, this is a 2021 revision we are using now. Previous revision, roof plates also, there was a condition not require welded identification. Now they removed it. Okay, because our question bank now we have corrected it. Our question bank we include roof wells and flange to nozzle neck wells. Now we removed the roof wells. Okay. Why I am telling the revision 653 we are following 2018 revision. 653 it says roof wells does not require. If you are making repair, does not require a welder identification. So forget about 653. As per 650, flange to nozzle neck. This is a flange nozzle, the neck weld. Okay, nozzle to flange neck weld does not require welder identification. This question regularly asked in the exam. Which of the following wells does not require welder identification? Okay. All other wells require welder identification. Every 3 feet we have to stamp it. But next condition, in lieu of stamping, the manufacturer keep the written record. So we can keep the record also. Okay, this is not highlighted. Okay, if you inside you want to highlight this one. In lieu of stamping, manufacturer records of the welder or the welder operator employed at the welder. Up to here highlight. That's all. Section 9. Maybe one question. Generally, there may be only one question, or sometimes 2 questions. Now we will go to the marking. Marking again may be one question only. So all storage tanks should have a nameplate. So what are the detailed nameplate? What should be the letter size in the nameplate? Minimum 5 millimeter. Minimum 5 by 32 inch or 4 millimeter. Now change it to 4. Okay. The nameplate shall include a means of letters number not less than 4 millimeter 5 by 32 inch. That is closed book question. So this is the nameplate information. Then please go to the next page. Regarding PWST, if the nameplate shows SR1, that means only flush type clean out fittings post well heat treated. SR2, flush type clean out. I told group 1 more than 12 inch, more than 1 inch, more than 12 inch nozzle, we have to do PWST when the thickness is more than 1 inch. Group 4 to 6, more than 2 inch dia nozzle, we have to. These are the highlight this one. Use SR1 only flush type clean out fittings and the flush type shell connection have thermal stress relief. Open book question. SR2, when thermal has been performed on flush type clean out fitting, flush type shell connection and the shell openings, NPS 12 and greater in size in shell plates, insert plate, thickened insert plates. SR3, that is for group 4 to 6 NPS 2. SR4, all flush type clean out, all flush type connection and the shell openings. SR5, complete tank. If you are doing a complete tank, PWST SR5. None when there is no PWST in the tank.
Sir, excuse me,
yes,
sir.
Please. Yes.
Sir, கொஞ்சம் ஸ்லோவா போங்க சார். கொஞ்சம் ரொம்ப ஃபாஸ்டா போற மாதிரி இருக்கு சார். ஃபாலோ பண்ண கஷ்டம் சார்.
Okay, no problem. So again I will repeat.
SR னா என்ன சார் ஆக்சுவலா அது?
Stress relief.
Okay.
Okay, now Okay, again I will repeat. If it is stamped as SR1, only the flush door, flush type clean out fittings, post well ready PWC done. Other things no PWC. SR2 means all flush type you have done PWC, and for group 1, 2, 3, the tank is made up of group 1, 2, 3 materials, and when the diameter is greater than 12 inch, we have done PWC. Clean out door one compulsory PWC generally. Whether it is a group 1, 2, or up to 6, all we have to do PWC. Okay, so if you are doing only flush door, flush type clean out fitting, the flush door you are doing PWC, then it is SR1. SR2 means flush door plus group 1, 2, 3 nozzle size more than 12 inch. SR3 means flush door, group 4 to 6 more than 2 inch. Then SR4 means all nozzle we are doing PWC. Flush door, all nozzles we are doing PWC. SR5 means complete tanks we are doing PWC. None means no PWC. So SR5 means complete tank, including all opening, everything we are doing PWC, SR5. Then where we have to attach a nameplate. Next one is important. So when you are attaching a nameplate, so highlight this one, the nameplate shall be attached to the tank shell adjacent to a manhole or a manhole reinforcing plate immediately above a manhole. Near a manhole only, we have to attach a nameplate. This is important. Then certification. Who will certify the tank? So he has to produce a certificate, manufacturer. So this is the manufacturer shall certify to the purchaser by a letter such as shown in figure 10.2 that the tank has been constructed in accordance with applicable requirements of the standard. So this is the certification letter he has to give, manufacturer certification letter. So to address, we hereby certify that the tank constructed for you in the location and it describes serial contract number, meets the application of 650 dash edition dash division. So manufacturer should certify. Okay. So again, who will? The manufacturer shall certify to the purchaser by a letter such as shown in figure 10.2 a tank has been constructed in terms of the applicable requirements. That's all chapter 10. Now we will go say Annexure A, optional design basis for small tanks. Now, Annexure A may be one question. Okay. Again, Annexure A is revised now. Okay, from the previous edition. So when you can use the Annexure A? If 650, if you are fabricating a storage tank as per 650, if the purchaser when owner wants, you want to fabricate as per Annexure A, you can go for it. What are the conditions you have to follow when you are using Annexure A? Condition number 1, maximum shell plate thickness allowed is 1/2 inch. If you are fabricating main code, there is no limit. There is no thickness limit. What is the maximum shell thickness allowed as per the main code? 1.5 inch. 1.5 inch. The chapter 4 it is there. 1.5 inch. It is 30, 38 mm, 32 mm. 40 mm. It will come 30. 12, 25, 38 mm. It will come 40 mm. They will round it. Okay, so we can go up to that. But when you are fabricating as per Annexure A, the maximum thickness allowed, shell thickness allowed is 1/2 inch. 1/2 inch means 12.5 millimeter. Point number 1. Second, the difference between the main code and Annexure A is main code stress. We will refer the table. Annexure stress is fixed 21,000 psi. For calculation, we have to use here 21,000 psi. Second condition. Then third condition. What is the third condition? Efficiency. There is an additional condition here. You see, yesterday we have seen RT. Less than 10 mm, we have to take spot RT like that. If you are following the section 8 RT requirements, then efficiency we can take it as a 0.85. If you are not doing RT, then we have to take it as a 0.7. Okay. Now we will just do the calculation, one calculation as per Annexure A. Then we will come back. All right. Please go to the page number A6. Please go to the page number A6. So this is the formula we have to use for the thickness calculation. 2.6D H minus 1G E 21,000 plus CE. Okay, 2.60 H minus 1 G. Okay, say now what is DH? I will say G. Say what is E? E can see here. Here A 3.4 is the previous, the same page. The joint efficiency factor shall be 0.85. Highlight this one. With the spot radiography required by A 5.3 by agreement between the purchaser and the manufacturer, the spot radiography may be omitted and a joint efficiency 0.7 shall be used. Same page only. Above the formula, there is this one. So efficiency we have to take 0.85 and correction. Now let us use the same tank. You remember the first day we have used to calculate the thickness 1 foot formula. What is the tank diameter we have taken? 40 feet. Okay, so we will take tank diameter 40 feet. What is the H value we have taken? First shell course 37, I think. Okay, H is 37 feet. G we have taken, I think, 0.9. Then what else? What is the other things records? So, correction allowance 0.1. So this is the main code. We used these values to calculate the first shell core thickness. You remember? Just use this up as per annex area what the thickness comes. Calculate using this formula. So what is the formula? Just tell me the formula. 2.6.
2.6 D 40 formula.
Formula solve.
2.6 D.
Okay.
Bracket H minus 1.
Okay.
G.
Hmm.
Divided by E.
Okay.
21,000. Plus.
Correction allowance. So, okay. Now, so E, I told you we will take it as a 0.85. So T is equal to 2.6 diameter is 40 into 37 minus 1, 36 into 0.9 divided by 0.85 into 21,000 plus 0.1. $0.288. This is the thickness you will find. Main code எவ்வளவு thickness வந்துச்சு உங்க நோட்டை பாருங்க. Now you have to add 0.1 portion allowance. You have to add 0.1 portion allowance. Then it will get to 0.2888. First shell course we calculated. You remember? What value we used there? I think almost same data. 0.19 என்னமோ வந்துச்சு. 0.19. They have taken 28. Then what is the okay? So just to change it 28, no problem. Height 28. Okay. So up 28 minus 1 or 20, 27. Okay, we will change it to 27. Let me compare, then only you can compare. This is 28 feet. Okay. Then the answer will change. So answer will change 2.6, 40, 27.9 divided by 0.85, 21,000 plus 0.1. It is coming 0.241. Just to copy this, Sriram, you are following?
Sir, yes, sir.
Okay, right. Okay. So this is it is a purchaser will decide. If you want to use annexure A, so original code, I think we got 0.19. Here we are getting 0.241 because efficiency we are using and we are using the fixed stress value. So we will have more things. But what is the condition is the thickness cannot be more than 0.5 inch. Here we are getting only 0.24 inch. So you can use it. Very rarely asked. Suppose please remember, if they clearly ask in the exam question using annexure A, then only you have to follow annexure A. Okay, otherwise annexure A, no, don't use. Huh? Okay, now what is the use of annexure A other than this? We can find out what is the capacity of the tank. So capacity means, suppose I have a storage tank. For example, let us take diameter and height, fill height. What is the diameter? Just tell me diameter. 40 feet. Okay. So height on the design liquid level on the 28 feet. Okay, same we will take. Because 28 minus 1, we took 27. Okay. Now, how many barrels oil we can fill in this tank? Formula is, capacity formula is 0.14 D squared H. This is the capacity for any tank. Just to calculate it, 0.14 D squared H. And I will show you, no problem. Just to calculate it. 0.14 D squared H. So what answer you are getting? Six two seven two barrels. You can fill this tank with this. This is the capacity of this tank. Only two things in annexure A is important. Barrel for any shell height. If you know tank fill height and diameter, we can calculate. They have given the table also. We can refer the table also. Okay, just to copy this. This is the formula we have to use.
Sir,
Yes.
sir, what's the main purpose of calculating T in annexure A and what is the comparison between T in annexure A and chapter
No.
4? Sir?
No, it is decided by the purchaser. That is the owner. If he says, no, I don't want to use the main code, fabricate me for a tank as per annexure A, he has to fabricate as per annexure. Annexure A is the addition, another option.
So,
yes.
When you compare with the thickness range, do you think annexure
A will have more thickness?
Okay. Okay, sir. Thank you.
Okay. Right. So now we will start from the, generally maybe one question from annexure A. Oh, sorry. Okay, we'll go from the annexure A starting. Maybe one question only. So highlight this one. The scope. The annexure provides requirements for field erected tanks of relatively small capacity in which the stressed components have nominal thickness no more than half an inch. That is very important. Close book question. So if you want to see, this is the optional design basis for small tanks. If you want to fabricate a small tank annexure A, the maximum thickness allowed is half an inch. Condition number 1. What is meant by stressed component? Next line. The stressed component include the shell and the reinforcing plate, side reinforcing plating, flush type and flush type shell connections, and the bottom plate that are welded to the shell. Then highlight the A12. This annexure is applicable only when specified by the purchaser and is limited to design metal temperature of above -20 and above -40 when killed fine. Generally above -20 only we have to use annexure A, and if you are using fine grain practice above -40 we can use it. Then please go to the next page. We will skip the A1A, we will go to the A1B. A1B, typical sizes, just to mark it as a open book. Corresponding nominal capacities barrel for tanks with 72 inches courses. So 72 inch means each shell course have 6 feet. So suppose one shell course will, two shell course minimum, there should be, if you are using annexure A, it is allowed to use only the shell course height either 6 feet or 8 feet. Only 6 feet or 8 feet only we have to use as per annexure A, each shell course. Minimum number of shell course, see, this is the tank height and the number of shell course. Suppose one shell course is 6 feet, what will be the two shell course? 12 feet. 3 shell course, 18. 4, 24. Multiply by 6, that's all. 5, 30, 6, 36, 7, 42, up to 10 courses you can go as per this annexure A. Okay. இல்ல annexure A ல fabricate பண்ணீங்கன்னா ஒன்னு 6 யூஸ் பண்ணும் இல்லாட்டி 8 யூஸ் பண்ணும், அதான் ஸ்டாண்டர்ட். If you are going for annexure A, original code there is no restriction. But if you are going for annexure A, either the course height should be either 6 feet or 8 feet. 8 feet there is a separate table. Okay. Now, how to calculate the barrel? Suppose I have 6 shell courses. That means height will be 36 and my tank diameter is say 40. It will fill 8060 liters. Okay. Yeah, barrel 8060 barrels it will cost. There is a formula here. C is equal to 0.14 d squared h. Using this formula only, the table was done. Now, you can see here some area, for example, if you have a 7 courses, what is the tank height? 42 feet, but it is, you cannot use when the tank diameter is 15 feet. When the tank diameter is, the dash means it is not allowed because the thickness will increase. When the thickness is more than half an inch, you cannot use this one. Wherever there is a dash is there, see, it is a maximum dia allowed is 73. Here, what is the dia? Here, what is the dia is here 90, but it's more than 73, you cannot use 8 course. These are not important for exam. Again, annexure A may be rarely one question. Okay.
Height is based on only design liquid.
Yeah, design liquid load. Height is always design liquid load. And then we'll go to the next one, A to B. This is the 96 inch. That means 8 feet shell course. 2, 16, 4, 3, 4, 24, 4, 32, 5, 40 like this. Formula is same here also. C is equal to 0.14 d squared of h. Then please go to the A-6 design. The maximum tensile strength before the joint F is applied as 21,000. That is important. This is important closed book question. If you are using annexure A, you have to take stress at a 21,000. Then tension each rest completed 12 inch above the center line of the lower horizontal joint of the course in question. This is also same 1 foot formula only. That's why we are using H-1. Okay, that is open book question. That is 12 inch, 1 foot above the horizontal joint of the each shell course we are taking. That is 1 foot. Then highlight A34, the joint efficiency a 0.85 with the spot radiography recorded by 5.3, or if spot radiography may be omitted and the joint efficiency 0.7 shall be used. Yes, maybe one question. Yeah, annexure A, it will mention in annexure A. That's all annexure A.
Sir,
Now we will go to the
A3.3, how do you are mentioning that it's 1 foot formula? They are mentioning as 1 foot, sir.
See, because you see the formula, it is given H-1.
Yeah, yes, sir. Yes, sir.
You can see here why we are -1. Any horizontal, for example, see, your tank height is say 28 feet, design liquid level.
Yes.
When you are calculating the bottom course, we are taking 27 feet. See, what is you are using in the formula H-1?
Yes, sir.
That is 27 feet means we are taking from here to here, design liquid level.
Yes, sir.
1 foot from the bottom joint only we are taking. That's why
Yes,
it is
sir.
called 1 foot formula.
Yes, sir.
If you take second shell course, again 1 foot from this joint.
Yes,
Third
sir.
shell course 1 foot from the joint. Everywhere H-1 means it is a 1 foot formula.
Okay, sir.
Height minus 1 foot. That is 1 foot formula.
Okay, sir. Okay, sir.
Okay.
Thanks.
Now we will go to the annexure B, recommendation of design and construction foundation of above ground oil storage tanks. Just not very important, just only one line will be. Highlight the B3.3, B-3. See, annexure B, I think some pages are missing in the printout, but if we correct it, we will give you the soft copy. We include in the soft copy because editing there was some mistake. but there is no question. The missing pages, there is no question. Okay, but we will give you soft copy. Soft copy, we will correct it. We will give you a soft copy. Then highlight this one. Unless otherwise specified by the purchaser, the finished tank grade shall be crowned from its outer periphery to its center at a slope of 1 inch and 10 feet. Okay, the tank grade அப்படின்னா tank level இருக்குல்ல slope, because we have seen the bottom plate slope 1:120. For that you have to make a grade also. Grade means the concrete. If you are using concrete or soil, that should be in slope. What should be the, this is about the this one. See, B1.1 about this recommendation of design and foundation. We talk about the foundation. Okay, there is a printing mistake. There's some 2 pages missing, but we include in the soft copy. We will give you the soft copy. Okay. So this is about what should highlight this one. What should be the slope if they ask open book? Unless otherwise, the finished tank grade shall be crowned 1 inch and every 10 feet slope. You have to maintain a foundation slope. This is a foundation slope. There we have seen is a bottom plate slope. Then what are the foundation type? Earth foundation without ring wall. Especially on 8 foundation should accomplish the following. Provide a stable plane for support the tank. What is the purpose of the earth foundation? Without a, if you are using without a ring wall, this should be the condition of the foundation. Limit overall settlement of the tank with the value compatible with the allowance. Provide adequate drainage and no settle excessively at the perimeter. It should not settle excessively. Just to highlight it, maybe open book. Then earth foundation with a concrete ring wall, B4.2. Highlight this one also. Large tanks and tanks with heavy or tall shells and are self-supported roof impose a substantial load on the foundation under the shell. Okay, so when you have a self-supported roof, means the roof total roof weight will be on the shell, because shell will have a what you call girders. There is no columns. Self-supported means there is no column. The entire roof weight will be on the girders and the options. So the shell will hold the load. This is particularly important with regard to delta distortion in floating roof. When there is some doubt whether the foundation would be able to carry the shell load directly, a concrete ring wall foundation should be used. When this type of you are using for self-supporting roofs, you have to use a concrete ring wall, because a soil will not withstand that much load. Okay, highlight this one. When concrete ring wall foundation is mandatory. Open book question. Then next page, P4.2, P-5, B4.2. When a concrete ring wall is designed, it shall be proportioned to so that the allowable soil bearing is not exceeded. The ring wall shall not be less than 12-inch thick. What should be the ring wall thickness? Should be at least 1 foot, 12 inch, 1 foot thickness. The center line diameter of the ring wall should be equal to the nominal diameter of the tank. Generally, shell should sit at the center of the ring wall. Ring wall oda center la sedu on the shell seat out. Then seismic loads and highlight this one as a minimum. The bottom of the ring wall, if founded on soil, shall be located 2 foot below the lowest adjacent finish grade. Okay, adjacent grade 2 foot the killer bottom of the soil, bottom of the ring wall. Highlight this one, open book. This wherever we mark it, we covered in your question bank. That's why we mark it. That's all in B. No, we have 2 more. Annexure C, very important. Annexure C and H is important. Generally, two question in annexure C, 2 question in annexure. Annexure C is external floating roof. Annexure H is internal floating roof. Okay, floating roof, there will be at least 3 to 4 questions. And please remember, if they ask any question regarding the floating roof construction, you have to refer only annexure C. Generally, they will be open book questions. Don't try to search in the main code. Main code, we didn't discuss about anything about the external floating roof. We generally discuss about the common roof. Any question asked about the floating roof, at least 1 question will be there in the exam. You have to search in the annexure. You have to remember Annexure C is external floating roof. Annexure H is internal floating roof. So what is the external floating roof? There will be no above, there is no other roof. The floating roof itself is the final one, only one roof. Internal means we have two roofs. One is a fixed roof. Below there is another floating roof. Most of the condition will be same, external and internal. Only there will be small deviation. Okay, first to highlight this one. Again, I am telling at least 2 questions will be asked in the exam regarding floating roof. Generally, they are asking 2 to 4 questions, open book question. So it is important. The annexure provides a minimum requirements that unless otherwise qualified in the text apply to a single deck pontoon and a double deck. So this annexure cover single deck pontoon, and what is I told a single deck means only end center there will be only plate, end only it will be floor, box type, that we call it say pontoon. Double deck means the entire will be a box type. Now highlight the C12. The roof type of roof and the seal to be provided shall be specified on the data sheet. If the type is not specified, the manufacturer shall provide a roof and seal that is cost effective and suitable for the specified service. Pan type floating roof shall not be used. Okay. Then these are not important. Highlight the C312 for close book question. The application of corrosion allowance shall be the matter of agreement between the purchaser and the manufacturer. How much corrosion allowance? So it will be agreed, but no, it is agreed between purchaser and the manufacturer. They will decide what is the corrosion requirement. Corrosion allowance shall be added to the required minimum thickness, and when no minimum thickness is required, added to the minimum thickness required for functionality. So corrosion allowance is the agreement between the purchaser and the manufacturer. That is a closed book question. Next one, what should be the thickness? Okay, sleeve and fittings on the single deck, annular pontoons and lower deck shall have minimum thickness of 6 mm for all pipe and plate construction. So the fittings should have minimum 6 mm thickness. That is open book question. Generally, what is the thickness of the roof? 5 mm. That is applicable to floating roof also. Roof will be 5 mm, but all fittings should have minimum 6 mm. Then shunt. Okay, what is the purpose of shunt? Shunt. Shunt is a conductor, electrical conductor. It is a, like a mesh, braided mesh, copper mesh. Any lightning, the ED minnala uludunu vachindi. So the tank should not catch fire. That high electricity should, okay, immediately pass to the ground. That is called the shunt. Okay, generally we used to tell village there will be always problem when it's a heavy thunder or lightning. ED minnala vandu pachana. When you are because I am near a very temple. நான் சாமி பக்கத்துல இருக்கேன். There they have a the இது வச்சிருப்பாங்க, கலசம் இருக்கும், அது வந்து அப்சர்வ் பண்ணும். Lightning இது வச்சிருப்பாங்க. Okay. Now all conductive parts of the external floating roof shall be electrically interconnected and bonded to the outer tank structure. Bonding grounding shunt shall be provided on the external floating roof and shall be located above the uppermost seal. This is open book question. Shunt shall be 2 inch wide by 0.4 mm thick austenitic stainless steel as a minimum. So this is open to question. What should be the shunt? The wire required? It's not a wire. They are using the mesh, braided copper mesh, because we need a high electricity, very high voltage, and it should not have resistance. It should immediately pass the current to the ground. So we should have a 50 mm, 2 inch wide and 0.4 mm thick austenitic stainless steel, and shall provide a equivalent corrosion resistance and the current carrying capacity of API 2033. Shunt spacing shall be no more than 10 feet. If you have a tank, every external floating, every 10 feet you should have a shunt. That is open to question. Now highlight this one, decks. Decks means that is a roof plate. Roofs in corrosive service, such as covering a sour crude oil, should be contract type designed to eliminate the presence of any vapor. It should be directly on contact with the oil. That is the purpose of the floating roof. See, what is the purpose of the floating roof? To avoid vapor losses. If you have a gap, oil can vaporize and it will go outside, it will be a loss, product loss. That only we are using the floating roof. Then highlight this one, C332. Unless otherwise specified by the purchaser, all shell deck plates shall have a minimum thickness of 4 point, and that is 5 mm, 3 by 16 inch. Okay, with a permissible ordering base of the 6 kg sheet. Forget about the gear, this one. Then deck plate shall be joined by continuous fillet welds on the top side. On the bottom side, where flexure can be anticipated, and support legs and other relative, full fillet weld not less than 2 inch long and 10 inch center shall be used on any plate flaps that occur within 12 inch. See, if you want to take plates, one side will be a continuous fillet weld, the top side. Bottom side, there will be a stitch welding. Okay, not a continuous weld. What is the stitch welding? It will be a 2 inch long for every 10 inch. Every 10 inch, just a 2 inch stitch, we have to weld it. This is for the floating roof. Then what should be the slope of the external floating roof? 1 inch, 1 inch 64. So I told always floating roof, we have to take the radius and we have to make a slope. Highlight this one. Top decks and double deck roofs of pontoon which are designed with a permanent slope shall be designed fabricated with a minimum 1 inch 64 to minimize accumulation of standing water when primary roof drains are open. The requirement is not intended to completely eliminate the isolated puddles. Okay, that is important. Then pontoon design. Now, suppose, see how a floating roof will be there. Okay. So this is the external floating roof. So this is the drain pipe. When there is any rain collected here, it should be drained here. These are the swing type of joints so that it will flexible joints. And this is a ceiling. The upper is called secondary seal. The lower is called primary seal. Upper one, this is a plate. We call it as a rim. It will directly touch with the shell plate. There will be no gap. The lower will be spring type to press that one. The press that plate on the press பண்ணிட்டு இருக்கணும். Otherwise, there should not be gap. Then this is external floating roof, secondary seals, firefighting systems, all these things. Then, so this is basically a double deck floating roof. You can see there is a 2 plates here. Completely, this is called a double deck. Single deck means central there will be only single plate. Then this is called a pontoon. Pontoon on the box type. This is a single type. Okay, you can see only one plate, that also will have the roof drain. Now, suppose roof drain is not operating. This is the internal floating roof. Internal floating roof, we have a fixed roof and there is a floating roof piece. Internal floating roof, there will be a fixed roof and a floating roof. And this is how the drain is working. This is the seal. Actual the seal. So I told the top one is called as a, which one? Secondary seal. Bottom one is called as a primary seal. Okay. Now, what is the requirement? Suppose the drain is not operating. Drain is plugged. Drain on the block. Then what will happen? The rain will store on the roof. So what the code says, how much load the roof should withstand without sinking. So this is the requirement. A 10 inch of rainfall. Rainfall today this centimeter rained. So they will tell in inches or centimeter. A 10 inch of rainfall in 24-hour period over a full horizontal tank with the roofs intact. Even there is a 10 inch rainfall for continued 24 hours, the roof should not sink. It should withstand that much weight of the water. That is the design condition. So highlight this one, open to question. This condition does not apply to double deck roofs provided with the emergency drain designed to keep water to a lesser volume that the roof will safely support. Then pontoon openings. Each compartment shall provide a liquid tight manhole with a minimum size of NPS2. pontoon on the compartment box circle, that we should have a manhole, and the main roof also we should have a manhole. So the pontoon compartment, we should have a manhole minimum NPS 20. That is open book question. Then please go to the next page, ladders. See, generally roof, I think I showed you video yesterday. Roof will have a rotating ladders. It will be flexible ladders. Now, how much a rolling ladders? Huh? Yeah, rolling ladder. How much the ladder should withstand the weight? At the midpoint, it should withstand at least 1,000-pound force or 4,045 Newton. So highlight this one. The ladder shall be designed a full roof travel, regardless of the normal setting of the roof leg supports. The ladder shall have a full length handles on both sides, and it shall be designed for, this is a open book, 1,000-pound force midpoint load with the ladder in any operating position. That line is open book. So it should withstand here 1,000-pound force midpoint load in any operating position. That is open book question. Now highlight this one, primary roof drains. What should be the size of the roof drains? Highlight the 1, 2, 3, 4, fifth line. A swing type check wall shall be provided at the inlet of the drains or single depth roofs to prevent backflow of stored product if leakage occurs. Then this is very important. Primary roof drain shall not be smaller than NPS 3 for roofs with a diameter less than 120 feet, or NPS 4 for roof with a diameter greater than 120 feet. If the diameter is more than 120 feet, the roof drain size should be 4 inch. Less than 120 feet, drain size should be minimum 3 inch pipe we have to use. Pipe or flexible hose. Then please go to the emergency roof drains. Then highlight this one. Double deck roof shall have minimum 3 open-ended. See, what is meant by emergency roof drain? They will have some pipes. Suppose the rainwater is storing, it will come outside and fill it. 3 open-ended emergency roof drain designed to provide drainage to prevent sinking of the roof during severe rainfall events. But நம்ம tankல எல்லாம் overflow வச்சிருக்கோம்ல, same like there will be overflow. If the rainwater storage, it will be overflow. So how many we should have? 3 open-ended emergency. That is a open book question. Then please go to the roof manhole. Pontoon, we should have a NPS 21 manhole. Roof, how many manholes? This is again open book question. C 3.1. Each manhole shall have minimum 24 inch and shall have a liquid tight gasketed bolted cover. So you should have a manhole cover also. How many manholes? There is a table next page. This is the minimum. Regularly asked exam question. The minimum number of manhole when the diameter is less than 202, 200 to 303, greater than 304. That is open book question. Now primary seal. Highlight this one. 313.13.5. The type of primary seal may be controlled by jurisdiction regulation. Types generally used are mechanical shoe seals and liquid mounted seals. So primary seal is bottom one. That is generally mechanical shoe type seals. Secondary seal. The type of secondary seal may be controlled by jurisdiction. If required by the purchaser, a secondary seal shall be provided by the roof manufacturer as specified. Then mechanical shoe seals. What is a mechanical shoe? Highlight this one. The metal bond is typically formed as a series of sheets that are overlapped or joined together to form a ring held against the mechanical device. For external floating roofs only, the mechanical shoe shield shall extend 24 inch above the 24 above and at least 4 inch into the liquid. That is not important. I think that's all.
Sir,
yes.
Do we need to mark the mechanical shoe seal or not, sir?
No need. How? Go to the C10. This is important. Last C.4.5. Drain pipe and hose systems of primary drain shall be tested with the water at a pressure 50 pound-4 per square inch gauge. So let us check whether the drain line there is no leakage. During the flotation test, the roof drain walls shall be kept open and observed for the leakage of the tank contents into the drain lines. So any leakage in the pipe, we have to check drain lines. What is happening if the drain line there is leaking? there is two possibilities. One is oil can mix with water, or even water can mix with oil. Both possibilities are. That's all annexure C. Then we'll go to the annexure H, internal floating roof. Generally, external floating roof is important. Generally, 2 questions they are asking. Here maybe 1 question, very rarely. Highlight this H21. The internal floating roof types shall be selected by the purchaser and consideration of both the proposed and future product service, operating condition, maintenance requirements, regulatory compliance, all these things. Then next page number H2, H 3.2 steel, then same thickness only. Steel conform to the requirements, then we should have 4.3 by 16 inches minimum thickness. Now, when you are using the internal floating roof, the fixed roof can be made of aluminum sheet also. That is allowed. Fixed roof you can use aluminum also. Okay, highlight the all types. H414. A vapor tight rim or skirt extending at least 6 inches above the liquid at the design flotation level shall be provided around both the internal floating roof periphery and the internal floating roof penetrations, except for drain designed for. So you should have a vapor tight rim. What is the seal? Vapor tight rim should be at least 6 inches above the liquid level. It should be there. Open book question. Then what should this is important? Page number H421. All internal floating roof design calculations shall be based on the lower of the minimum design specific gravity or 0.7, regardless of any higher specific gravity specified by the purchaser. When you are calculating thickness, you have to use a 0.7. Suppose your stored product specific gravity is less than 0.7, you have to take the value. Maximum allowed is 0.7. Then this is important. Page number H5, last paragraph. Only aesthetic stainless steel hardware shall be used to join aluminum and stainless steel components to each other to carbon steel. That is important. When you are joining aluminum to carbon steel, we have to use a Boultonite all made up of stainless steel. We have to use a stainless steel only. When where acceptable to the purchaser and the manufacturer, aluminum hardware may be used to join aluminum components. Aluminum shall be isolated from carbon steel by a aesthetic stainless steel spacer, elastometric pad, or equivalent protection. The use of plated fastener shall be permitted only when components. Generally, when you are joining aluminum to steel, we have to use stainless steel. That is an important point. Then peripheral seals, page number height. So this is highlighted. This one almost same. When an internal H441 floating roof has 2 such devices, one mounted above other, the lower is the primary peripheral seal and upper is the secondary peripheral seal. Where there is only one such, is a primary seal, regardless of the position. When you have 2 seal, upper one is called as a secondary, lower one is a primary. When you have only one, that is primary. Then what type of seal material we have to use? This is open book question. Crude oil, the seal material should have made up of this material, sealing. And all peripheral seals and their attachment to the floating roof shall be designed to accommodate plus or minus 4-inch local deviation between the floating roof and the seal. That is open book. Even if you do understand, no problem. Just read the question and answer. Then this is very important. Recently asked the question. All fastener and washer for insulation of seal joints, including fabric, shall be aesthetic stainless steel. That is important. When you are using seal joints, you have to use only aesthetic stainless steel. Fasteners means bolt and nut washer, you have to aesthetic stainless. Then penetration. H45, columns, ladders, and the other rigid vertical appurtenances that penetrates the deck shall provide with a seal that will permit a local deviation plus or minus 5 inches. That is open book question. Highlight this one, tank circulation vent, page number H10. Peripheral circulation vents shall be located on the tank roof and meet the requirement 553. So they are above the seal and internal floating the maximum sitting bench shall be 32 feet. So suppose you have bench, every 32 feet you should have a bench. Yesterday also we have seen one 32 feet. What is 32 feet yesterday? Settlement. Every maximum 32 feet. Very. Then manhole, page number height H-11. At least one fixed manhole complying with the standard with the nominal opening of 24 inch or larger shall be provided in the fixed roof for maintenance ventilation purpose. If used for access to the tank interior, the minimum clear opening shall be 30 inch. Suppose you want to go inside, then you should have 30 inch open. That's all. Then H, annexure I. These are not important.
Sir, H ஓட first page மட்டும் ஒரு நிமிஷம் காமிக்கிறீங்களா சார்? அத மார்க் பண்ண வேண்டாம். H ஓட first page.
Okay.
மார்க் பண்ண வேண்டாம் சார். அதுல
no issue. Yeah.
Okay sir.
Now,
Thank you, sir.
only one paragraph is important. So I-2. The permeability of leak detection barrier shall not exceed 1 into 10 to the power minus 7 cm per second. Just to highlight this one. I2, page number I2, D, point number D. Highlight this one, mark it as a open book. Leak detection barrier. See, what is leak detection barrier? You can see the sketch here. Suppose this is our tank bottom, this is our sandbag. They will insert some pipes here. Even concrete, they will have some pipe. Purpose is, if the bottom is leaking, the leakage should be immediately collected outside. There are two reasons. Once, you should know immediately that the bottom is leaking. When the leakage come outside only, you should know. But if it is inside here, it will spread. It will damage the foundation. It will damage the bottom also. So that is called a release prevention barrier, RPB. Next to 653, we will discuss about the RPB. Release prevention barrier means it should channel. Channel means it should bring back immediately to the outside. Any leakage in the tank leaking, the inspector should know it immediately there is a leakage. It should come outside. How it will come outside? You should have pipes everywhere. When you have complete concrete pad, they will make a groove on the concrete on the all dimensions. So any leakage, groove na slope, so slope it will come outside, leakage will come outside, so that we can prepare ourselves for corrective action. So tank is started leaking. Leak ஆகிறது நமக்கு உடனே இன்ஃபார்ம் தெரியும். அதுக்கு பேர் தான் release prevention barrier. So even soil, they will use a pipe because soil will absorb. That's why they will use a pipe there. ஆமா, 4 direction, more than 4 direction வந்து see, suppose this is your tank pad. Suppose this is your tank pad. They will make a groove like this. இந்த மாதிரி groove இருக்கும் எல்லா சைட்லயும். So from the center, anywhere any leakage, it will come outside. Sand pad na they will use pipes. ஆமா, எதுனா concrete they will make a groove. Concrete la groove you can make it. Which pad you are using? Your site, which pad you are using? That foundation. Sand. You are not installing pipe inside? Okay, right.
That pipe is already small bore. Small bore throughout all the pipe. So that's why it will be collected and
collected?
No,
yeah.
On the outside have the hole.
Pipe இருந்தா pipe உள்ளார போடும்ல, அதுக்காக ஹோல் போட்டுருப்பாங்க. And the liquid will collected and come outside.
Fiber pipes, they are wide.
Right. Okay, so this is the one. So you can see here, crushed stone ring wall also will have a pipes inside. Everywhere there will be a pipe inside. Now we'll go to the annexure M. So please go to annexure M. It is there in your book. M is there. The first line only important. We already know that annexure specifies 650 and 200 to 500 degree Fahrenheit. That is close book also. Because we marked there, we didn't mark there. Okay. Then these are not important. Then we go to the annexure U. Ultrasonic examination instead of in lieu of radiography. In lieu means instead of radiography. You don't have you? Huh? So you two again. So only one paragraph is important. Page number U-3. Highlight this one. Investigation criteria. Reflected that produce response greater than 20% of the reference level shall be investigated. Alternatively, for method or technique do not require amplitude records longer than 40% of the applicable shall be investigated. What is the meaning of this? When you have a UT screen, for example, this is your UT screen. I'm talking about A scan. Sometimes you will find a line like this. What is this called? DAC, distant amplitude correction curve. Then the system will automatically draw a 50% DAC and automatically draw a 20% DAC also. First one, suppose you have any signal which is crossing the 20% DAC, it should be investigated. That is the first condition. That is a reference. If it is anything 20%, we have to check. Compulsory, we have to analyze this. Second one, suppose you are not using the DAC. There is no DAC. The height we will generally mark in percentage. 20, 40, 60, 80, 100. So what code says, suppose there is no DAC used, any signal crossing the 40% mark should be investigated. Okay. Next one is, suppose you have the DAC, anything crossing 50% is called as a defect. Sometimes you can accept it because it is slag. Slag have some length acceptable. When you are accepting which is crossing greater than 50%, or here which is crossing 75%, then you should record it. You should mention in the report. There is a signal which is crossing 50% DAC, but it is accepted because of the size. The length is less. So these 2 points are important. So highlight this one. That is the first point we already noted. Reflector that produce a response greater than 20% of the reference level shall be investigated. Alternatively, for methods or techniques that do not use amplitude recording, reflector longer than 40% shall be investigated. That is open book question.
இது முன்னாடி இன்னொரு क्वेश्चन சொன்னீங்களா? அது என்ன சார்? இது முன்னாடி மார்க் பண்ணது?
மார்க் பண்ணல, இது ஒண்ணு தான் மார்க் பண்ணேன். அது பின்னாடி இங்க இருக்கு. இங்க இருக்கு பாரு.
ஓகே சார். இது மார்க் பண்ணிட்டேன் சார்.
இது இந்த flag documentation. In addition to the data, written documentation shall be produced for each unacceptable flaw, and the acceptable flaw either exceed 50% reference level or 70% of the non-amplitude technique. Now there is one more point. This is important. Suppose you are doing UT. When you are UT, you can measure the defect depth. Now the defect depth shows it is on the surface. Generally, the problem with the ultrasonic testing is it can detect a defect accurately when it's more deep. But if it is on the surface, it will miss. So what code says, by UT, if you are marking some defect on the surface, it should be confirmed with the MTRPT. But MTPT says it is a linear defect. Linear means like crack, lack of vision. Repair is mandatory. No need about, don't worry about the ultrasonic results. Okay, so this is important. Flaws categorized as surface flaws during UT examination may or may not be surface connected. Therefore, unless the UT data analysis confirm that the flaws is not surface connected, a supplement surface examination MTPT shall be performed with applicable for all surface flaws. Any flaws which are detected by MTRPT and characterized as planar are unacceptable regardless of the length. No, if it is MTPT showing some linear indication, you have to repair it. Okay, that's all API 650. Okay.
Sir, annexure whole இல்லையா sir?
இல்ல அதெல்லாம் இல்ல. Okay, so just I will please take 653 because we will have break around 10:40, not now. So please take 653. Sit down. இடையில இது வைக்கணும், அலுமினியத்தை கூட இது வைக்கணும், இடையில பேட் வைக்கணும். பேட் வச்சுட்டு ஃபிட் பண்ணணும். இப்போ ஸ்டெயின்லெஸ் ஸ்டீல் போல்ட் யூஸ் பண்ணும். Directly there should not be contact between stainless steel and aluminum. Okay. அடுத்த லைன்ல கீழே இருக்கு பாருங்க, there should be a pad should be provided அப்படின்னு கொடுத்துருக்கோம். Okay, so we will start 653 tank inspection, repair, alteration and reconstruction. The most important code of the 653. Right. So we have go one by one chapter. First one, what is mean by inspection? Okay, online, can you hear voice? No issue, right? Hello?
Yeah, we can.
Okay, okay, no problem. Now, first tank inspection. So what are the different type of in-service inspection we have? First one, roof inspection. I just take introduction for 10 minutes, then we will go through the code. Shell inspection and bottom inspection. So it is major 3 type of inspection. Now, you remember I said the rule in new construction, the bottom should be minimum 6 mm, shell should be minimum 5 mm, roof should be minimum 5 mm. 653 for in service, it is almost 50%. Bottom should be minimum 2.5 mm. When the bottom thickness go below 2.5 mm, we have to repair the bottom. Okay, same. Shell thickness less than minimum 2.5 mm. 6 mm, here 2.5 mm. Off is 3 mm, but here 0.1 inch allowed. 0.1 inch allowed. Okay, there are certain conditions, just I will. So shell also 2.5 mm allowed. Roof 2.3 mm allowed. It can go up to 2.3 mm. 2.3 mm means 0.09 inch allowed. If it is less than, then only we need a repair. First point. Now, generally, what are the different type of inspection we have? One is called a routine in-service inspection. So routine in-service inspection means just going around the tank, not climbing the tank. Just in the ground level, we will check the condition of the tank. Any problem you are seeing, there is any leakage or any vibration, or just what is the condition from the ground level, it will be carried out by the operator. No need inspector. Okay. Generally, it should be carried every month. Every month, the operator should check, go around the tank, check the condition of the foundation, whatever he can say from the bottom. Next one is called as a external visual inspection. So external visual inspection should be carried out by the API inspector. It should be carried out by the API inspector. What he do? He will, every level he will check. It is done for the shell. Okay. Now, what is the external inspection rule is? To understand the external visual inspection, first you think what is mean by remaining corrosion allowance, what is mean by corrosion rate. First you have to understand these two terminologies. For example, a tank is constructed as per 650 and the nominal thickness. Nominal thickness means with the corrosion allowance or without the corrosion allowance? With the corrosion allowance. Nominal thickness, what thickness you are constructing the tank. For example, nominal tank is say 0.5 inch. And the tank is installed in year say 2005. 2005, the thickness was 0.5 inch. So this is the nominal thickness. Nominal thickness is including corrosion allowance. Then we check, say after 10 years, for example, 2015, the thickness say 450 inch. Okay. Then required thickness. So T required, say 0.3 inch, T required. So what is the mean by T required means it is, we are talking about the shell. We are not talking about the bottom or roof. Okay. Now 0.5 is the nominal thickness. Nominal thickness means with the corrosion allowance. 0.45 after 10 years we are taking reading. The thickness is 0.45. The minimum required of the tank is 0.3 inch. For example, in this tank. Now, this first reading is called as a, as per 653, T previous. And the second reading is called as a T actual. This reading is called as a T minimum. T minimum record or T minimum both are same. If you say this type of data, you can calculate first thing, what is the corrosion rate? So corrosion rate symbol they are using N. Capital N is the symbol for corrosion rate. Formula is T previous minus T actual divided by number of years. So what is our T previous reading? 0.5 minus T actual 0.45 divided by 10. So if you calculate it, so 0.5 minus 0.45 divided by 10. So it is 0.005 inch per year. Or sometimes if you want to use in mils per year, you have to multiply by 1000. It is R 5 MPY. MPY means mils per year. IPY means inch per year. Okay. These are the terminology you should understand first. Okay. Now multiply 0.005 multiply by 1000. See 0.005 inch multiply 1000 will give the 5 MPY. We have to multiply because 1000 mil is equal to 1 inch. Suppose question they are giving mils, you have to use everything mils. You cannot use a part of the 6 inch and part is in mil or converted in inch. How to convert mil to inch divided by 1000. Okay, is it clear now? So how to call? So I will finish it. Then you can write. The correction rate calculation is very simple. It is not yet finished. Please wait. It is not yet completed. Still we have more steps. Correction rate for correction rate calculation we need 2 readings. It is different from 510 and 570. 510 we have 2 types of correction rate, 510, 570, long term and short term. 653 is very simple. Only one correction rate. Only we need 2 readings. First reading is called T previous. Second reading is called T actual. The previous reading minus latest reading. Actual reading, what is the latest reading we have to take? We have taken. Okay. Is it clear? Correction rate. Now, next one we have to calculate is RCA, remaining correction allowance. Remaining correction allowance. So the code is using symbol as a RCA. What is the remaining correction allowance formula is T actual minus T minimum. That is a formula. T actual minus T minimum. So what is the T actual here? 0.450 inch minus 0.30, sorry, 0.3 inch. So we will get 0.15. So 0.45 minus 0.3. So 0.15 inch. This is the remaining correction allowance. So this much correction allowance is left out. So please write this, then we will go to the next page.
Sir?
Yes, please. No,
Sir, in 653, we don't have like a long-term correction rate, short-term.
Yeah. I told you there is no long-term, short-term. Only short-term. This is actually short-term correction rate.
Yeah, short-term.
Yes, please. Yeah. ஆமா கால்குலேஷன் ஃபார்முலா 650 ஃபார்முலாவில் கால்குலேட் பண்ணது. ஃபார்முலா கால்குலேட் பண்ணி ப்ளஸ் குறைச்சல் ஆனது தான் நாமினல் திக்னஸ். 1 foot ஃபார்முலா யூஸ் பண்ணோம்ல, அதில் கால்குலேட் பண்ண திக்னஸ் இது. ப்ளஸ் குறைச்சல் ஆனது ஆட் பண்ணீங்கன்னா இந்த திக்னஸ். இல்ல பாயிண்ட் ஒண்ணுங்கிறது கிடையாது. இட் கேன் பி எனி திங், டிபெண்ட்ஸ் ஆன் ஹவு மெனி இயர்ஸ் யூ வாண்ட் சர்வீஸ், வாட் இஸ் த எக்ஸ்பெக்டட் கொரஷன் ரேட். அப்ப பாயிண்ட் ஒன்னு நம்ம சொன்ன போன காலம், அது ஸ்டாண்டர்ட் ஒன்றும் கிடையாது, ஜஸ்ட் எக்ஸாம்பிள். Yeah. Each shell course can have different correction rate. But when you are going for tank inspection, generally, as per 653, internal inspection is not carried out for the tank shell. Internal inspection is carried out only for the check the condition of the bottom. It is entirely different from 510, 570. Don't confuse with the 510, 570. Is it okay? So we have two values now. The correction rate is calculated at 0.005 inch per year, and the remaining correction allowance is calculated at 0.150 inch. That's all, not inch per year. It is 150 inch. It is for shell only. Bottom, we have different formulas, different things. Forget about the bottom. Because this page, there will be around 4 or 5 questions they are asking in the closed book. So you should understand what is meant by T actual, what is meant by T previous, what is meant by T before. Then how to, is it okay? Yeah. Now if you have the data, then I can calculate. There are, again I will write, it is for applicable or for only shell. The first inspection cell is called routine in-service inspection. Inspection. So there is no formula, it is a fixed interval of 1 month. Every month we have to carry out. There is no formula for this. The next one is called external visual inspection. The formula is lesser of RCA by 4N or 5 years. This is the rule. Then third one is UT thickness measurement. So there are two rules. If correction rate unknown, the correction rate is unknown, you don't know what is the correction rate, then rule is we have to take 5 years. Measurement. Then second, if correction rate is known, lesser of RCA by 2n or 15 years. So please write and calculate what is the external visual inspection for this, the tank you have written, and what is the UT thickness measurement, because corrosion rate we already know that. Corrosion rate we have calculated it. So just to write this, what is the routine in service? There is a fixed one month, every month you have to do. What is the external visual inspection period? RCA by 4n or 5 years, whichever is less. We already calculated RCA, we already calculated N. Calculate it. What is RCA by 4n? How much coming RCA by 4n? So it is coming 7 point. If we apply the rule, then it is 0.15 divided by 4 multiplied by 0.005, which will come 7.5 years or 5 years. We have to choose which one is the lower value. So the answer is 5 years. If you calculate here, 0.15 divided into 2.00. Yes, please.
N is corrosion rate, right?
Yeah, N is corrosion rate. I written here. You can see N, corrosion rate. So it will come 15. So our value also 15 only. So there is no problem. 0.005. N is the corrosion rate. N. Corrosion rate 0.005 inch per year. Hello? Have any doubts? Please ask, because this is very, very important. There will be around 5 questions they are asking in the exam based on these 3 formulas. Again, I will repeat. Routine in-service inspection, there is no formula. It is a fixed interval of 1 month. External visual inspection, there is a formula and there is a value. Value is 5 years. Formula is RCA by 4n. RCA is the remaining corrosion allowance, and N is the corrosion rate. So we have to calculate the value. If it is less than coming 5 years, you have to take that value. Suppose if it is coming 4 years, then we have to take 4 years. That's why I put lesser of RCA by 4n or 5 years. And for UT thickness measurement, if the corrosion rate is unknown, what is meant by corrosion rate is unknown? Suppose you are installing a fresh tank in a new area. You don't know what is the corrosion rate. We are going to store a new product. You don't have any idea. You don't have a similar service also. Then you don't know corrosion rate. So first 5 years you have to take the reading. So we have to take thickness measurement up to 5 years. Suppose you know the corrosion rate. Corrosion rate can be known in 2 ways. So because we are running the tank, we know what is the corrosion rate, or there is one thing called a similar service. Suppose you take a particular local area, if you have some 5-6 tanks, one tank is already operating, all you are going to store the same product. That tank, you can take it as a reference corrosion rate. No need to go for internal inspection. You can take it as calculate this one. That is called a similar service analysis. Okay, that's why if you know the corrosion rate, then the rule is lesser of RCA by 2n or 15 years. But in our case, both has come 15 years. Suppose which it is less than one value come less than 15 years, that value you will take. 5 years. 5th year. Yeah, 5 years. Yeah, we have to establish the corrosion rate. after 5 years. Is it clear? Because these formulas are very, very important. Bottom roof, there is no formula at all actually. Bottom, we have a separate formula. Okay. So let us start with any online, please. If you have any doubts, please unmute yourself and ask questions.
Yes, sir.
Yes, okay. So we will start with so this is the inspection. Now, what is meant by repair? Repair, there are two types of repair. Major repair and a repair. So as per code, because there is a confusion in code itself, actually. 575 before they have different rule, 653 have different rule. Now they put it almost uniform rule. I will put it simple. Repair means you are to make a tank in suitable operation condition. That is called a repair. Suppose there is a defect, you are grinding and welding, that is a repair. And any fillet weld patch you are put, that is also a repair. Major repair means any nozzle greater than 12 inch you are installing below the design liquid level, major repair. Okay, and any welding, butt weld, generally, if you are doing more than 12 inch, that is also called a major repair. Just a minute. Hello. Sir. Sir, I'm prepared. Okay. That is a major repair. Now, what is meant by alteration? We will go very slowly. Sriram, if you are going, I'm going fast to stop it. Yeah? Okay.
Okay, sir. Thank you, sir.
What is alteration? Alteration. Alteration means altering the tank shell height. Suppose you are increasing the shell height or decreasing the shell height, it is called alteration. Okay. There is one more thing is considered as a alteration. What is one more thing is considered as a alteration? There is one thing called a new bottom installation. New bottom installation means you are going for, you have your old tank. After 30 years, you are going for inspection and you find it, the bottom is severely damaged, severely corroded. And you decide repairing this bottom is a waste. Then we will install another bottom. So another bottom, how they will install? They will completely clean the tank and the bottom they will fill with the what you call the grade, whatever you want, whether you want to soil or concrete. Then they will cut the shell. Same, for example, a 6 inch to 1 feet height. They will fill the concrete or soil. Then they will cut. They will install the new plate, and the new plate will hold the weight. They will install a new bottom. There is a separate chapter for new bottom installation. We will see. But when you are installing new bottom, what will happen? The tank height is altered. Tank height is reduced. So it is considered as a alteration. Okay. So I told repair, any defect removing is considered as a repair, even attaching a patch plate. So even the patch plate means considered as a permanent repair in tank. Whereas in piping and pressure vessels, any fillet welds are not considered as a permanent repair. If you go in 510, 570, all fillet weld patches are considered as a temporary repairs. But here there is no temporary repair concept. Even if you put a patch plate, it is a permanent repair. What is major repair? I told any weld, butt weld particularly, it is not a fillet weld. You are doing more than 12 inch welding, replacing a plate more than 12 inch, installing a nozzle more than 12 inch. These are considered as a major repair. One more is considered as a major repair. Suppose I told you yesterday, settlement. So what code says? How much settlement is allowed as per 650? The total settlement, if it is exceeding 2 inch, we have to stop the filling and we have to inform the purchaser. Now, so okay, hydro does forget it. During in service, if the tank is shortly settling, then what we will do? During inside, you are storing the product, but the tank is settling excessively, then we have to repair the foundation. We have to correct the foundation. How we will correct the foundation? There is one option. They will empty the tank and put arrangements on the around the tank periphery and jack the tank. Tank, they will lift it by jacking. Okay, you can see YouTube videos. If you search YouTube tank jacking, there are many videos are uploaded. They will jack it, then they will go inside bottom, they will repair the bottom. Any tank jacking is considered as a major repair. Even though you are not doing any repair on the tank, if you jack the tank, lift the tank from its position, it is considered as a major repair. Then what is the, you call it major repair, what is the problem? If anything called as a major repair, hydro test is mandatory. If you are lifting the tank by jacking, after keeping it, you have to again do hydro test. Okay. So that is about the repair. Is it clear? Any repair, yeah. See, anything more than 12 inches is considered as major repair. Without doing repair, if you are lifting the tank, then it is considered as a major repair. Then you have to do hydro test. Hydro test exemptions are there, we will see later. Then what is alteration? I told you, installing a new button is alteration, and increasing the shell height or decreasing the shell height is considered as a alteration. Then there are two things. One is missing here: relocation and reconstruction. These two terminologies are different. Relocation means you are
considered as alteration.
Which one?
Only these two are considered as alteration.
Yeah, these two are considered alteration, but the 650, I told you there is a small confusion. They give major repair alteration in same title. Okay, the two are only considered alteration. Only what are considered alteration? Installing a new bottom, and I told you increasing or decreasing the shell height. Okay.
Unless fighter, there is a replacement of nozzles without
No. That is a different thing. That is a different thing. Okay. Now, what is relocation and what is reconstruction? Relocation means entire tank you are lifting and installing in another location. You are lifting the entire tank and transporting to other location and installing a reconstruction means you are cutting the tank into pieces, transporting to another location, and again rewelding, reconstructing there. That is called a reconstruction. Reconstruction, all rules you have to follow. Almost 650 rules will come. Peaking, banding, plumbness, everything will repeat here. Reinforcement, welding, everything will repeat. So 2 chapters, almost 650 will repeat. So with this introduction, let us go to the chapter 1. Scope. Okay. So section 1 will have around 4 questions. So section 1 will have around 4 questions. What happened? Tank is entirely different. Okay. Now, again, the difference between 510, 570 and 653 exam is in 510 and 570, in-service inspection is the API code, construction is the ASME code. If you go 510 exam, construction is covered in ASME section 8. In-service is API 510. If you go 570, construction is ASME B31.3. In-service is API 570. So, if you refer 510 and 570, there will be no reference to section 8 or B31.3. But here in 653, construction code also API, in-service code also API. So everywhere in 653, they will refer 650 also. Refer the 650. So when you are reading 653, you should have 650 book also with you. There will be cross-reference. Refer this chapter of 650 like this. Okay. Oh, now, not now. I'm just telling. When you are preparing exam, so many area it is. Now, 650 coming to picture. See, if you go. Okay. Just a minute. Okay. If we take 650, the first edition was issued in 1961 only. Before 1961, it was API 12C, welded storage tanks. So before that, the storage tank was constructed as per the API 12C. 1961, the first edition of 650 has come. Okay, so up to 1958, it was API 12C. Suppose you have a tank constructed in API 12C, still you can use 653. 653 can be used to tanks constructed as per 650, also as per the 12C also we can use. So then you get confusion. That's why I'm showing this. And this is Annex A given. So when the edition comes, so the first edition API 612C was 1936, long before our independence. Okay, 1936, July 19. So up to 1958, it was API 12C. Then from 1961, API 650. Okay.
சார்
Now,
இதுல
please go-
வந்து நம்ம ஏபி 510ல அடண்டம் 1998 முன்னாடி அப்புறம்
அதெல்லாம்
60
go to
அந்த
confuse that. அதோட கன்ஃபியூஸ் பண்ணாதீங்க. இது வேற அது வேற. கிராஸ் ரெஃபரன்ஸ் வேண்டாம்.
சரி சார்.
Right. Please highlight this one. This standard covers storage tanks built to 650 and its predecessor API 12C. That line is important. Close book question. So which of the what is the scope of 653 is? It covers tanks built by 650 and 12C. Then what it provides the minimum requirement for maintaining the integrity of tanks after they have been placed in service. Only when they started service, 653 will come into picture. Before service, it will be 650 only. Okay, construction and addresses inspection, repair, alteration, relocation, and reconstruction. So here they cover relocation also. Even the title it is not covered. That is important. Now, what is the scope of 653? It covers from the foundation, bottom, shell, roof, attachment or upper trusses. Upper truss means the level gauges, everything it will cover. The scope is limited to foundation, bottom, shell, structure, roof, attached upper trusses, and nozzle to the face of first flange, first thread joint, and first welding connections. Next slide also important. Many of the design, welding, examination, and the material requirements of API 650 can be applied in the maintenance, inspection, rating, repair, and alteration of in-service tanks. So you have to follow 650 requirements. Now, suppose there is a conflict between 650 and 653. So your 650 is telling something. For example, I will give you the conflict. What is peaking banding allowed as per 650? Peaking na deformation of the vertical joint. Banding na deformation of the horizontal joint. Both are half an inch. Both are half an inch. Peaking also half an inch, banding also half an inch. As per 653, peaking half an inch, banding 1 inch allowed. Now, which one we will follow? 653 only we have to follow. This is called a conflict. 650 is telling something different, whereas 653 is telling something. So this line is important. In the case of yes, yeah, horizontal as per 653 1 inch. 650. Even the plumbness. They are 1/200, here 1/100. These are called conflict. When there is a conflict for in service, we have to follow only 653. Okay. In the case of apparent conflict between the requirements of standard and 650 or 12C, this standard shall govern for tanks that have been placed in service. That is closed book question. Now, this standard employs the principle of 650. However, storage tank owner operators, based on the consideration of specific construction, may apply the standard to any steel tank constructed in accordance with the tank specification. What is this meaning? Suppose you have a tank which is not constructed as per 650. The tank is constructed as per your local government rules. Still, you can use 650. Even though most of the 653 requirements, they refer to the 650. If you want any other tank which is not constructed accordance with the 650, for example, you can have your Indian regulation tank or you can have your local regulation. Still, if you want to use 653, it is allowed. So you can see here. This standard employs principles of 650. However, storage tank owner operators, based on the consideration of specific construction, may apply the standard to any steel tank constructed with accordance with tank specific. Any tank we can use it. Now, the standard is intended for use by organizations that maintain or have access to engineering and inspection personnel. That line is important. So it is intended to use by the engineering and inspection personnel. That line is important. Technically trained in tank design, fabrication, repair, and construction. Only these people will use the 653. Engineer and inspection personnel trained in design, fabrication, repair. The next one is, suppose you don't have the design details, follow the 650. When design and construction details are not given and are not available in the as-built standard, details that provide a level of integrity, current edition of 650 must be used. Suppose I told any tank you can use it. The tank specification does not give any construction details, you can refer 650 also. Now, the standard recognizes the fitness for service assessment. So what is meant by fitness for service assessment? Okay, now if you take, for example, 650, say 5 ones grade 70, SA 516 grade 70. I will take, just understand this. SA 516 grade 70 tank material. What is the tensile strength of material? Tensile strength is equal to 70,000 psi. Where you can find the tensile strength, the 650 table is there. Just to see the stress table. Grade 17 or 70,000. But what is the stress we are using for calculation in 650? That's why I asked you to refer the 650 table. What is the SD we are using and SD we are using? As per 650. Chapter 5. Stress table இருக்கும் பாருங்க. இல்லங்க stress table னு இருக்கும்ல. 1 foot formula stress table. No. This. SD. SD या ST या? 20? Okay. ST. Which one?
ST வந்து 28 tensile strength is 70,000.
எது SD யா? Okay.
28,500 and ST is 28,500.
Okay. Now,
Sir,
what is the meaning of this? Yes, please.
sir, 25,300, sir.
Here,
ஆமா sir.
okay, no problem. Okay. Now, what is the meaning of this? First, what is meant by tensile strength? Tensile strength is the maximum load a material can withstand. That is the meaning of the tensile strength. If you, for example, SA 516 grade 70 can withstand 70,000 pounds per square inch. But what is the maximum load we are giving as per 650 is maximum we are giving 28,500 only. Forget about this. This is lesser value, so we will take this value. Now, how much reduction we are giving? 70,000 divided by 28,500. So, what is the reduction we are giving? Calculate it. 70,000 divided by 28,000. So 2.5 times approximately we are giving reduction. What is the meaning of this? Suppose I have a tank shell of 25 mm thickness, actual thickness, but my originally required thickness is only 10 mm. Only 10 mm is required because I am giving 2.5 times less value in the calculation. So my calculated thickness is coming more. You understand this? இதுக்கு ரேஷியோ போடுறோம் 70,000 28.5 approximately 2.5. அதோட மீனிங் என்ன அப்படின்னா இப்போ ஸ்ட்ரெஸ் வேல்யூ வேர் யூ ஆர் யூசிங் இட் take any formula, stress will come at the bottom. Stress will always come at the bottom denominator. That means suppose if I put 70,000 here, then the calculated value will be lower by 2.5 times. The ST எல்லாம் denominatorல தான் வரும். Yes, please.
Can you repeat, please? Because
yeah, see the tensile strength instead of 28,500, if you use 70,000 in the formula, then your calculated value will be 2.5 times lesser than the what is the you are calculating now, because this is called as a safety factor of tank. So this is approximately we are using 2.5 times. I'm telling approximately some 2.4 something, no problem. Now, first understand this. This is what is the, it is not very important, but understand. Originally, if a tank is having 25 mm, but even if you have 10 mm, it will withstand the pressure. You know, because originally it is like, then why we are using 25 mm? To compensate for mistakes may happen in design, fabrication, welding, NDT, PW. Everywhere there is a possibility of mistakes. Even people do some mistakes, still the tank should withstand that. It should not fail. That's why it is applicable. See, pressure vessel have 3.5 safety factors. Suppose pressure vessel we will use instead of 25 mm, how much we will use? 35. Piping 3, 30 mm we will use. Tank 2.5. Now, okay, this is the one. This is how the tank is constructed. Why we are using a 2.5 times higher thickness? The reason is I told there may be a mistake or there may be a problem in design or materials or fabrication, welding, NDT, PWC, everywhere there are possibilities because we cannot control 100%. So we don't want to take a risk. We are going for the safe side. Okay. Now, what is meant by fitness for service? If I have a crack in a tank, for example, like this, and there is no other problem, the tank will not fail. The tank will run with a crack safely. But when the crack reaches this level, it will fail. Okay. Now, you are inspecting a tank and there is a crack here like this. If you can accurately predict the crack growth, then you can stay even with the crack. This tank will run for another 10 years safely. This analysis is called as a fitness for service analysis. Or a defect order, we want to run a tank with a it can be crack, it can be reduction in thickness, it can be what you call lamination, or it can be any other problem. We have a problem which is generally not acceptable, but we are analyzing whether we can run with a problem for another period or another some particular period. That is called fitness for service analysis. Fitness for service analysis. Why we are, how fitness for service analysis working on the safety factor? We are utilizing the safety factor because most of the structures we have excess thickness. So the extra thickness we are using it. Okay. I hope you understand. Okay. Okay. Even though there is one question, what is fitness for service? There is a methodology. Okay, to analyze whether you can run with a flaw. Flaw means any defect or any discontinuity detectable by ND. Okay, highlight this one. This standard recognizes fitness for service assessment concepts for evaluating in-service degradation and pressure containing components. APA 579 fitness for service provides the detailed assessment procedure and acceptance criteria for specific types of degradation. So each type of degradation, lamination, corrosion, pitting, crack, we have 578 separate chapters, but it accepts 5653 accept the fitness for service. See, we have two options. If you find some repair, some crack or reduction thickness, either you can go for repair or you can go for fitness for service. Without repairing also we can run it. But somebody should give guarantee that it will not fail. Who will give the guarantee? 579. Okay. Compliance. Who is responsible for compliance with the 653 is owner operator. The owner operator has the ultimate responsibility for complying with the provisions of the standard. The application of the standard is restricted to organizations that employ or access to authorized inspection agency, but all inspection will be carried out by the authorized inspection agency. Please remember, who is responsible for implementing 650? Manufacturer. There it is not the owner operator. Tank construction, the responsibility 650 is manufacturer, but here it is the responsibility of owner operator. But owner operator directly will not do all things. So it will 653 through authorized inspection agency. Who is authorized inspection agency? They are responsible for the inspection. Okay. Jurisdiction. Now, I told you if there is a conflict between 650 and 653, which one you have to follow? 653. Suppose there is a conflict between 653 and the local government rules, which one you will follow? Local government rules you have to follow. You cannot violate a local jurisdiction, we call it as. But 653 is more stringent. Stringent means more strict than 653. You can satisfy both. So you have to satisfy the rules of the local government body. Okay, very important. If any provision of the standard present a direct or implied conflict with any statutory regulation, the regulation shall govern. However, if the requirements of the standard are more stringent than the requirements of the regulation, then the requirements of the standard shall govern. Now, next page. இதெல்லாம் close book la da irukum. See, 653 most of the question will be close book except calculations. Procedures shall be developed according to the guidelines given in APA 2015 or 2217A that will include safeguard of personal health, safety and the prevention of accident, fires, and explosion. That highlight this one. Okay. Then this is open to question. Finally, procedure must comply with any federal or state regulations pertain to confined space. When you are going for confined space, it is called confined space entry inside tank. You have to follow the local, federal, and the state regulations. So that is the end of chapter 1. So before going chapter so we will complete the question also simultaneously. Okay, so hope you can answer it. Yes, please start for So which of the following types of tanks APA 653 covers? So answer is 650 and 12C. So answer is 650 and 12C. C. Okay, next.
APA 653 provides the requirement for protection of the following.
Above ground petroleum storage tanks. Okay, next.
APA 653 provides.
Let him read. Okay. Okay.
APA 653 provides for all but of the following with regard to its above ground storage.
Which one it is not covering? Operation. It covers repair, relocation, and alteration. Okay, next.
The scope of APA 653 is limited to all of the following.
Except this tank mixing motor. It covers tank bottom,
Tank
roof, and foundation. Okay, next.
The APA 653 standard states that many of the requirements for design, welding, and machines to APA 2C can be applied.
So answer is repair, inspection, rating, and alteration. Okay, next.
In the case of apparent conflicts between the requirement of APA 653 or its predecessor APA 2C, standards are known for that and have been placed.
So which one will cover? 653 only we have to follow. Next one.
Which of the following standard can be used for evaluating
So standard used to evaluate in service 579 fitness for service. Okay, next.
The use of APA 653 is intended for organizations that have personnel who are technically trained and experienced in each of the following.
Okay. So answer is design, fabrication, repair, construction, and inspection. Okay, next.
Design and construction details are not available in the provide a legal of integrity equal to the current use of what standard.
We can use a 650. If it is not given, we can use 650. Okay, next.
Ultimate responsibility for compliance with the standard is
owner operator. Okay, next.
According to APA 653, many provisions what governs with the APA 653
So 653 govern. So if it is 653 more stringent means strict, then we have to follow 653 because you can automatically satisfying the local jurisdiction. Okay, next.
Safe working practices will comply with what requirements.
Okay, so save this one. Federal or state. This question is very important. Recently asked exam question. So confined safe, you have to follow local, federal, and state regulation. That's all chapter 1. Okay. Now we will go to the chapter 3. Okay. So chapter 2, normative references. So some standard numbers you should know. Very rarely one question will be asked. Very rarely. For example, what is APA 579? Fitness for service. Highlight this one, but they are not very important. 580 RBI, risk-based inspection. Then this was asked in one of the exam. What is 2015? Requirements of safe entry and cleaning petroleum storage tanks. 2201 hot tapping. This is important. Hot tapping, there is a separate chapter in this one. Hot tapping, what is hot tapping? Installing a nozzle when the tank is in service. Okay. 2207, preparing tank bottom for hot work. 2217A, guidelines for safe work in inert confined space. Confined space entry is 2 to 170. Then SNTTC only everybody knows, personal qualification certification in NDT. So that's all. These are not very important, very rarely asked. Now we'll go to the chapter 3, terms and definition. Again, there will be 4 to 4 questions, around 4 questions in the chapter 3. First, what is alteration? So the definition of alteration is any work on a tank that changes the physical dimension or configuration. I told you in the introduction, increasing the tank height, shell height, or reducing the height, or installing a new bottom. Then there are 2 standards. One is called as-built standard, and if you next page, there is one thing called a current applicable standard. 3.11. What is the difference between as-built standard and current applicable standard? What is meant by as-built? As per which standard the tank was constructed, that is as-built. What is the current applicable standard? Which construction standard you are going to use now? For example, as-built standard may be APA 650 year 2000 revision. Current applicable standard may be APA 650. What is the latest 2020 revision, like that? It can be same. If the tank is constructed now only, we can use same. Suppose you don't know which code the tank was constructed. Then what code says which year? If you know the year of construction, that year 650 take as a as-built standard. You don't know whether it is constructed as per 650 or not. We don't have idea. Then code says, suppose you know the tank was constructed in 1990. So 1990 edition, you take it as a as-built standard. Suppose you don't know which year the tank was constructed also, take the latest edition as a as-built standard. Because we don't have any other option. Okay. Highlight this one. The standard such as APA are used for construction of the tank component in question. If the standard is not known, the as-built standard is the standard that was in effect at the date of installation of the component. If the date of installation of the component is unknown, then the current applicable standard shall be considered as a as-built standard. If you don't know anything, what we can do? Take the latest edition as a as-built standard. Okay, that is closed book question. Now we will go to the current applicable standard. Next page, then we will cover. What is current? The latest edition. The current edition of the standard such as APR UL that applies to the tank were built today. So current construction code is called as a current applicable standard. That is important. UL na the writers UL standard. Okay. Still there. Their EP is sorry, American they are used. Now, authorized inspection agency. I told you, implementing 653 is the responsibility of the owner operator. But he cannot do directly everything. He will appoint the authorized inspection agency. Then who is the authorized inspection agency? They are responsible for all inspection activities. First thing. Who can be authorized inspection agency? First one, owner can have their own inspection department. Inspection organization of the owner user, owner operator. Please remember, it can be only the inspection department of the owner operator. It cannot be operation, maintenance, what you call the fabrication. They cannot work as the authorized inspection agency. Only inspection people can work as the authorized inspection agency. So point number 1, inspection organization of the owner operator. Suppose owner says, no, I don't want to appoint this much people. Okay, he can hire means he can hire from the insurance company, or he can hire from the local government also, or he can appoint a third party. So any 4 of this can be authorized inspection agency. Very, very important. Inspection organization of the owner operator, inspection organization of the jurisdiction, inspection organization of the insurance company, independent organization approved by the owner. That means third party, we call it as. Please highlight. One of the following that may employ the above ground storage as per the APA. Inspection organization of the jurisdiction in which the above ground storage tank is operated. Inspection organization of insurance company which is licensed or registered and does the above ground storage tank insurance. Owner operator, owner above ground storage who maintain inspection organization for his equipment and not for sale or resale. He cannot inspect and resell it. He cannot use the inspection agency for commercial purpose. An independent organization or individual under the contract under the direction of owner operator, recognized otherwise not prohibited by the jurisdiction. So again, I will repeat. Who is authorized inspection agency? Inspection organization of the owner user, owner operator. Okay. Now, second one, inspection organization of jurisdiction, inspection organization of insurance company or independent organization approved by the jurisdiction. Okay, next one. What is mean by breakover point? What is mean by, see, some terminology you will understand. First one, what is critical zone? Very, very important. Now, this is my shell. This is my bottom plate. Okay. In the bottom plate, from the shell inside 3 inch, this is called critical zone. So generally where it will come critical zone, in the annular plate it will come. Okay. It is not one year. This is all around the tank. If you tank all around the tank, from the shell inside, how much area we have to take? 3 inches. Why it is called a critical zone? In this area, some repairs are not allowed. Some type of repairs are not. For example, patch plates are not allowed. Some type of repairs are not allowed. So critical zone, many exam, this question was asked in the closed book question. The critical zone, but answer they will give 3 inch from the bottom, 3 inch in the shell. It is not 3 inch in the shell. Only bottom plate only it is a 3 inch. From the shell inside this area only critical zone. You understand this? Now, what is meant by control tank? What is meant by candidate tank? Suppose I told you there is one thing called a similar service analysis. What is similar service analysis means? I have 5 tanks in a location. One tank is operating for long period and I know all corrosion rate. Take it as a reference, and other tanks no need for the inside inspection. Only we can take on stream. On stream means from outside we can check. Which tank corrosion rate is known is called as a control tank. Which tank is corrosion rate is not known as a candidate tank. Now, what is the difference between student and a candidate? You are student here or candidate here? You are student. When you are attending class, you are student. When you are appearing for exam, you consider as a candidate. You see all APA corresponds, they will address dear candidate. They will address dear candidate. Here we are student. Okay, no problem. So candidate tank means corrosion rate unknown. Control tank means corrosion rate already established, which you will use for the, is it clear? Now, third one is what is meant by breakover point. Yesterday we have seen about the settlement. Only one type of settlement we have seen. That is a uniform settlement. There is one thing called the edge settlement. Edge means, suppose this is my tank shell again. In the bottom, the edge it is settling. Edge area it is bending like this because of the foundation problem. Edge, okay, this settlement is called edge only, it is settling where the shell is heating, and from the where the edge setting start, where it start from here, this area is called a breakover point. So what is the breakover point? Where the bottom plate start bending. That is called a breakover point. Again, this is a closed book question. Okay, very important. What is the edge over edge is this one and the breakover point. Okay. We'll go to the code book. Is it okay? This much slowness? So critical zone, don't get confused. It is not in the shell. Because answer they will say just you should not remember only 3 inch, because they will give 3 inch in the shell, 3 inch in the bottom. It is bottom plate from the edge of the inside edge of the shell. Yeah, settlement. No. Which one? Settlement.
Due to settlement, maximum affected zone is.
No, it is not only bottom. It will affect shell also, but the uniform settlement affect the shell. Nozzle will be affected. Okay. Now we will go to the next one. Breakover point. Close book question, very important. The area of the tank bottom where settlement began. Highlight this one. Candidate tank, the tank for which corrosion rate are unknown. That is kind of close book question. And this is recently asked close book question. What is meant by change in service? A change from previous operating condition involve different properties of the stored product, such as specific gravity or corrosivity or different service condition of temperature and pressure. That is called change in service. That is also close book question. Then control tank, the tank for which corrosion rate and service history are known and documented. Then critical zone, the portion of the tank bottom annular plate within 3 inches of the inside edge of the shell measured radially inward. This terminology we have to understand, very, very important. Current applicable, the current edition of the standard that applies tank were built today. That is also close book question. Then who is the examiner? The examiner means NDT technician. Okay. What is his responsibility? What is the responsibility of NDT technician? See, who is responsible for NDE? It is the authorized inspector, not examiner. Authorized inspector, that is APA 653 inspector, is responsible for the NDE. So as per code, it's not NDT, it is NDE. Okay. But what is the responsibility of examiner? When authorized inspector asking to do the NDT, he has to do the NDT and interpret as per the acceptance criteria. Acceptance criteria, we have to follow section 8. We have to follow 650. 650 says we have to follow section 8. And he will write a report whether accept or reject. But he will not evaluate as per 653. What is the meaning of as per 653? He will tell there is a crack, we have to repair. He will not decide whether it should be repaired today or next shutdown. It will be decided by only AP inspector. Okay, that decision he will not take. He will see, he will evaluate results as per the acceptance dated and write accept or reject. That's all. He will not tell we have to do the repair now immediately or by tomorrow like this or next shutdown. It will be done only by the inspector. Okay. Unless owner approves, he will do. A person who assists the inspector by performing specific non-test examination on above ground storage and evaluate to the applicable acceptance criteria, but does not interpret the results of examination according to 653, unless specifically trained and authorized to do so by owner operator. Then what is meant by external inspection? A formal visual inspection conducted or supervised by the authorized inspector to assess all aspects of the tank as possible without suspending operation. I told the external inspection, what is the formula? RCA by 4N or 5 years, whichever is less. Fitness for service, very, very important. A methodology whereby flaws contained within a structure are assessed in order to determine the adequacy of the flawed structure for continuous service without imminent failure. Hot tap, identify the procedure for installing a nozzle in the shell of a tank that is in the service. Only shell nozzle. Then insert plate, highlight this one. We know what is insert plate. When an insert plate is equal to the full height shell, it is considered as a shell plate. That is important, open to question. Then internal inspection, a formal complete inspection, supervisor, author, inspector for all aspects of internal tank. Then here, I told a major alteration and a major repair, they clubbed together actually. Now, if you take this one, only installing a new bottom is a alteration. All others are major repair. What are the major repair? I told you a simple clue is anything more than 12 inches major repair. Okay, see, you can see installing a shell penetration larger than NPS 12, installing a bottom penetration within 12 inch, removing and replacing a shell plate beneath the design liquid level more than 12 inch, removing, replace annular plate more than 12 inch, complete or partial and replacement more than 12 inch, a non-metallic repair that contributes more than 1/2 of the strength and more than 12 inch, then this is actually alteration, installing new bottom and jacking a shell also major repair. All others are major repair. But I don't know why they club together. Then product side, you know what is product side? Inside, underside, inside of the called product side, underside is called the soil side. The side of the tank that is contact in the stored liquid. Now, what is meant by recognized toughness? Just 1 minute, I am coming. Okay, what is meant by recognized toughness? Now, how I know a tank, in-service tank, will not fail by brittle fracture? So, brittle fracture opposite is the toughness. So, if you know the toughness, then you can say it will not fail brittle. Brittle exact opposite of the toughness. How I can confirm a tank is there in service for many years? How I can confirm that it will not have a brittle failure problems? If I know these 5 points, you can confirm it. First one, a condition that recognized condition that the material of the component is deemed accepted by use of provision any of the following. Section 5.3.2. 5.3 will state based on the addition of the tank. Suppose you know which year the tank was constructed and you have a document that impact test was done on the tank, then you can say we already tested it, it will not fail. Or suppose you don't know the whether impact content, you have to cut the tank shell. From the tank shell or plate, you have to cut it and send for impact test. The addition of the tank shell or by coupon testing. Coupon testing means you will cut the from the shell plate and send for impact test. If it passes impact test, no problem. It will withstand it will not have a brittle fracture problem. Then based on the thickness. What is based on the thickness? Generally, as per 653, any tank thickness less than half an inch. We are talking about the shell only. Again, don't confuse with the shell only. Any tank less than half an inch, up to 0 degree Fahrenheit, it will not fail. Okay, any tank, if it is less than half an inch, there will be no brittle fracture problem when it is operating more than 0 degree Fahrenheit. That is based on the thickness. Then based on the design metal temperature. What is mean by design metal temperature? If the temperature is more than 60 degree Fahrenheit, whatever the thickness, it will not fail by brittle fracture. More than 60 degree Fahrenheit, it will not have a brittle problem. If the thickness is less than half an inch, up to 0 degree Fahrenheit, it will not have a brittle problem. And the fourth one is based on the exception curve. That is the same exception curve we will see. For example, thickness is 0.6 watt temperature, 0.7 watt temperature, the curve we will see. So this is called the recognized toughness. Now, there is one more point which is missing here. Suppose I have a doubt. The tank might become brittle during service. I have a doubt. Service, there is a possibility. Then how to check it, whether it become brittle or not? You have to do the hydro test. If it passes the hydro test without brittle failure, then during service, it will not fail. That's all. The point is missing here. So how you will recognize the toughness, how you confirm the toughness of the material. If you know the addition of the tank and you have the records, you can say it is impact tested. Or second, I told you can cut a coupon from the shell and send it for impact testing. Third option, if the thickness is less than half an inch, it will not fail. Fourth one is more than 60 degree Fahrenheit it is operating, it will not fail. If it is more than half an inch, then there is a temperature curve is there we have to follow in the chapter 5. And I told if you have a doubt, you have to conduct a hydro test. Once you pass a hydro test, it will not fail in service. Okay. Next one, reconstruction. What does it mean by reconstruction? I told cutting into pieces and transporting to another location. Then you will ask what is the size of the piece. It depends on how you are going to transport. You have any work necessary to reassemble the tank that has been dismantled and relocated to a new site. So you have to dismantle and relocate it. Then what is the repair? Work necessary to maintain a tank to a condition suitable for safe operation. That is very important. That is the definition of repair. Repair definition of any condition to restore a tank to a condition suitable for safe operation. Then repairs include both the major repairs and repairs that are made. Examples of repair: removal and replacement of material, re-leveling, jacking of a tank shell, bottom or roof, adding or replacing a reinforcing plates, repair flaws such as tear gouges, all are considered repair, but it includes repair and major repair. Again, they have a concern. I told you, jacking is considered as a major. But you can see the sentence. they include the repairs and major repairs. They are repairs, not major repairs, sorry. Okay, then who can do the repair? Repair organization. See, repair organization, who is the repair organization physically doing the work, repair work? The contractor. First one, owner can have their own fabrication department, do the repair, or a contractor can be approved by the owner, or you can contractor approved by the jurisdiction, government approved contractor. Very simple. The organization that meets any of the following: owner operator of above ground storage tank who repair or alter his own equipment, a contractor whose qualifications are acceptable to the owner operator of above ground storage tanks, one who is authorized, acceptable, or otherwise not prohibited by the jurisdiction, who makes repair according to standard. That is again closed book question. Then what is similar service? I already told you what is similar service. The process by which a correction rate and inspection interval are established for a candidate tank are using correction rate and service from a control tank for the purpose of the next inspection. So control tank means we know the correction rate. Candidate tank means we don't know the correction rate. So from the control tank, we'll take it as a reference. Instead of going inside the tank, we will avoid the shutdown. That is the logic of this. Then soil side, the side of the tank bottom that is in contact with the ground. Then what is meant by unknown thickness insert plate? This all why we have not highlighted. We have already highlighted in 650 the thickened insert. What is thickened insert plate? When the thickness is greater than 3 mm. Okay. Unknown toughness. If you cannot prove the toughness any of that method, then it is called unknown toughness. Recognized, if you can prove, you can say confirmly it will not fail brittly, recognized. Unknown means a condition that it cannot be demonstrated the material of component satisfies the definition of recognized. Highlight that also. Yes, please. Okay, so that is the end of chapter 3. Again, we will review the question, then we'll go back. Yes, please. Who is going to read? Yes.
As-built standard is
What is as-built standard? Standard use.
AP 650 and the oldest is
What is the answer? Which one is the answer?
any of the
Answer is any of the above, because the standard used for the construction, the standard that was in effect, the date of installation, if the date of a component unknown, then the current applicable. All are definition of the as-built. Okay, next.
which of the following is not considered as authorized inspection agency?
So which one is not an authorized inspection agency?
independent application.
Maintenance.
Okay, so inspection organization of the jurisdiction, correct. That is authorized inspection. Insurance company, that is also correct. Owner operator. So this one, insurance company, D. So insurance cannot certify another person. They can use also. Okay, next.
The area on a tank bottom where settlement begins in
That is called the definition of the breakover point. Okay, next.
tanks for which corrosion rates are not known is
Not known is called as a candidate tank. Okay, next.
the tanks for which corrosion rate and service history are known and not known is
Control tank. Okay, next.
the current edition of the standard such as APA standard or UL standard that applies if the tank that today is
Current applicable standard. Okay, next.
Because 3 inches above the underground.
Answer is A or C.
A and C.
Both. The portion of the tank bottom, only A is the answer. Okay.
An examiner is
Okay. A and B. So you cannot interpret as per the 653. Okay, next.
methodology whereby flaws contained within a structure are assessed in order to determine the adequacy of the flawed structure for continuous service without imminent failure is fitness.
It is a definition of fitness for service. Flaws, now there is a discontinuity detectable by NDT. Okay, next.
Which of the following is alteration?
All of them. I told only new bottom. We have to alter the tank. Okay, next.
Which of the following is considered as repair?
Hmm. All of the above. You can see just all of the above are considered as a repair. Okay, next.
Repair organization is an organization that meets which of the following?
Hmm.
The above, sir.
Any of the above. All are the definition of a repair organization. Okay, next.
The process by which corrosion rates and inspection control are established for a candidate and using corrosion rate and survey.
So that is a similar service assessment. Okay, next.
A condition that exists when it cannot be demonstrated that the material of a component satisfies the definition of repair is toughness.
It is called a unknown toughness. Okay, that's all. Right. We will go to the next chapter. Chapter 4. Now, if you take 653, only 2 chapters are very big chapters, and most of the question will be asked only these 2 chapters. One is chapter 4 and chapter 9. Chapter 4 is a big chapter. There will be around 15 questions. Chapter 9, there will be around more than 15 questions actually. This 2 chapter only will have more questions. Little bit tough chapter. Chapter 4 and chapter 9. Okay, so we will start chapter 4. We'll go slowly only. So first, suitability of service. It is a very lengthy chapter actually. Maybe we'll do afternoon also. We will do 1.5 hours. Okay, then tomorrow also. Okay, it will take more than 2 days actually. 6 to 2. I told you these 2 codes are very important. Other codes will go little fast. Now, when we have to check whether the tank we can continue with the service or we have to make repairs. Okay, when the results of the tank inspection show that a change has occurred from the original physical condition. Suppose we are inspecting a tank, we have severe corrosion, then we have to check whether you can continue our service. And evaluation shall be made, determine suitability of continuous service. That is important, closed book question. When inspection shows there is a deterioration or damage is there, then we have to evaluate it. So if you see 650, how 650 is organized? First in chapter 5 design, they will start with the bottom, annular plate, then shell, then finally roof. 653 ulta, reverse. They will evaluation, we will start from roof, then we will come to shell, then finally evaluation bottom. Okay, this is organized like this. Now, what are the roofs we have to evaluate? There are 3-4 points I will say. When there is a severe corroded area, we have to mark a 100 square inch area by marker. 100 square inch means 10 inch by 10 inch. How you will calculate area? Length into width. 10 by 10 100 square inch, and you have to average the thickness in that area. You have to take thickness reading and average it. If the average thickness is less than 2.3 mm, that area to be repaired. Point number 1. If the average is more than 2.3 mm, you can accept it. Even 2.3 is accepted. 2.3 means 0.09 inch. Okay. So again, I will repeat condition number 1 for roof evaluation. Any 100 square inch area, the average thickness is less than 0.09 inch. The area should be repaired. Repaired means you can make a weld build-up. It is allowed. Weld build-up and the grain. Or you can replace, cut and replace. That is about the roof. Or you can put a patch plate.
It means all the roof.
Wherever you are seeing the corroded area. It is not all the roof. We can see by physically corroded area. Point number 1. Another one is columns. If roof columns, you have to check carefully because roof column outside may be looking good, inside may be corroding. So whenever you have a doubt, you have to go for a UT thickness measurement. Third one is, suppose you see roof pitting, then inspector should have idea whether the before next inspection pitting become holes, then water will enter. So that pit should be repaired. Okay, this is the 3 important things. Okay, so please highlight this one. Roof plates corroded to an average thickness less than 0.09 inch in any 100 square inch area, or roof plates with any holes through the roof plate shall be repaired or replaced. Very, very important closed book question. Then the next one, fixed roofs. Roof support members, rafters, girders, columns, and the bases shall be inspected for soundness by a method acceptable to the responsible inspector. Next, that is who will inspect? Responsible inspector. That line is important. Next line, particular attention must be given to the possibility of severe internal corrosion of pipe columns. Corrosion may not be evidenced by the external visual inspection. That also important. Column, we have to check whether it is corroding inside by doing the UT thickness readings. The next page, floating roofs. Highlight this one, 4231. Areas of roof plates and pontoon exhibiting cracks or puncture shall be repaired or the affected section replaced. Holes through the roof plate shall be repaired or replaced. Any cracks you have to repair it. This you can all guess it. That's not a very sticky thing. The next one is important. Area pitting means pitted shall be evaluated to determine the likelihood of through pitting occurring prior to the next schedule. Suppose there is a pitting, we have to check whether it's only a small pitting or deep pitting. Deep pitting, you think before next it will become a hole, then we have to fill. How we will repair the pitting? By welding. If so, affected area shall be repaired or replaced. Then 4233, that's also important. Roof support systems, perimeter seal system, appurtenances such as roof rolling ladder, anti-rotation device, water drain, and venting shall be evaluated for needed repairs and replacement. Then guidance for evaluation of existing shall be based on the 650 annexure C for external floating roof, annexure first for internal floating roof. However, upgrading to meet the standard is not mandatory. That is open book question. You don't need to upgrade it. Okay. Then external pressure. So these are some sections are given. This if they ask open book, not very important. If applicable, the roof supporting structure and the roof to shell junction shall be evaluated effects of a partial vacuum. The criteria annexure B followed. Partial vacuum, you have to use annexure B, open book question. Then M shall be considered before changing service at a temperature above 200. If it is operating above 200, annexure M we have to follow. That is also closed book question. So annexure M you should know. Other annexure no need. Then lower temperature. If the operating temperature is changed to a lower temperature than the original design, the requirements of current applicable standard for the lower temperature shall be met. That is, current applicable standard is a keyword here. So if it is going for lower temperature, you have to follow the latest edition. Current applicable standard only we have to follow. That is a keyword. Not the original one.
Sir, ஒரே நிமிஷம் சார்.
Yes, please.
சார் அந்த அப்பன்டஸ்னா சொன்னீங்க. அது அப்படின்னா சொன்னீங்க முன்னாடியே சொன்னீங்க சார். இப்போ முன்னாடியே அது மறந்துச்சு சார் டக்குனு.
எதுங்க?
அப்பன்டஸ்.
அப்பன்டஸ்னா அந்த அட்டாச்மென்ட் லெவல் கேஜ் அதெல்லாம் அப்பன்டஸ்னு பேர். சப்போர்ட்டிங் திஸ் ஒன். வெசல் ட்ரைங் டு சப்போர்ட் பண்ற லெவல் கேஜ், சாம்பிளிங் இது கேஜ் அதெல்லாம்.
Okay sir.
Now we will go to the tank shell evaluation. It is a big chapter, but I will split into part. Okay, first one, how to evaluate tank shell. We will go very slowly, but if you don't understand, please ask. Now I have a tank. The shell evaluation. I am going for inspection. So first I am checking this. Just to follow this, what I'm saying. We are checking the tank and there is a corroded area in a tank shell. You can visually seeing that. Then what you have to do is mark the corroded area. This is the corroded area. I have here also the second shell course also a corroded area. Now, what is the difference between the corroded area in the shell number 1 and the shell number 2? By seeing this, what I drawing, what is the difference? What is the difference between the shell number 1 corroded area and the shell number 2 corroded? So this is the near the weld. This is the away from the weld. So for away from the weld, for calculation, we have to take E is equal to 1. If it is near the weld, E is not 1. It can be less than or equal to 1. So first we will see how to find out the E. Okay, we will go step by step. So first E. Now So please go to the page number 4-6, highlight the E. Page number 4-6, highlight the E. The E is the original joint efficiency for the tank. Use table 4.2, E is unknown. Then this is the next one is the important. E is equal to 1 when evaluating the retirement thickness of the corroded area away from the weld, at least the greater of 1 inch or twice the plate thickness. Suppose if it is at least 1 inch from the weld, away 1 inch from the weld, or 2T, whichever is greater we have to take, then E is 1. Suppose it is close to the weld, how to find out the E? We have to go to the table 4.2. Please go to the table 4.2-4-8, page number 4-8. Page number 4-8. This is the very important open book question. Regularly asked how to find out efficiency. It depends on which year the tank was constructed. You see, if it is constructed, I told there are two ports. One is AP 650, another one is a 12C. If the constructed tank is constructed from 1982 present, it is butt weld efficiency is 1, basic standard. Basic means 650 main code. But it is a but is having annexure A, then 0.85. Annexure A without RT 0.7. We have seen annexure A also. How it was constructed. Basic standard means AP 650. It was constructed as per 650 main code. Efficiency is 1. That's why 650 main code formula there is no efficiency because E is equal to 1. But annexure A, if you are taking radiography 0.85, no radiography 0.7. But it was constructed to 1961 to 78. Then annexure A no RT 0.7, basic standard 0.85. That time annexure DG also there, then it will be 1. Then if it is constructed up to APA 12C, there is a big list. It was asked last exam. Yeah, unknown material, but told what is the, we don't know which year it was, which standard it was constructed. But if you have butt joint, we have to take 0.7. That is important. Highlight to mark it as a open book. Suppose you don't know which year it was constructed, which standard it was constructed. Then butt joint, we have to take this table regularly. They are asking open book. How to find out the efficiency? Please remember, sometimes they will confuse. So suppose I am asking a question. A tank was constructed, say in 1995, okay, with annexure A with no RT, and the corroded area is 1 feet away from the bottom joint. What is the joint efficiency? Efficiency is 1. Away 1 foot away from the bottom joint of Bina, it is a place, basemental only we have to take. Efficiency is 1. Please remember this efficiency is applicable only when the corroded areas is close to the well. It is away from the well, it doesn't matter which year it was built. Basemental plate efficiency always 1. Efficiency, when there is a joint, then only it will come efficiency. Plate, there is no joint. When it is corroded on the plate, it will take efficiency 1. So please read the question carefully. Away from the weld, always E1. What is a joint number? You have to follow the step.
2 types of cell thickness. So
Suppose thickness is C. For example, your shell thickness is say 2 inch. 2 inch. So what code says 1 inch or 2T, whichever is greater. So what is the mean 2? Suppose cell thickness is 2 inch, 2T, how much it will come? 4 inch. Only if it is 4 inch away, then we will take E1. If it is less than 4 inch, we have to take the table. We have to follow the table. That is the meaning of this. Okay. Now you know how to find out the efficiency. Is it clear? Efficiency regularly asked in the exam. Okay, and that will be a open book question, your efficiency. I will repeat. Any corroded area near the weld, we have to take E from the table. Suppose you don't know which year constructed, there is unknown also there, but joint, lap joint, everything they have given. Just read the carefully and answer it. If it is away from the weld, it doesn't matter which year it was built. Okay, efficiency is always 1. What is mean by away from the weld? The corroded area from the weld at least 1 inch or 2 times thickness, whichever is greater, we have to consider. First one is clear. Okay. Now we will take only one area for evaluation. Okay. Next what you have to, so I will take only this area. Okay, no problem. Next area, I have to check by random thickness measurement. I will do the UT, and whichever the lower thickness, I will get some lower thickness. the lowest thickness is considered as a T2. So in a corroded area, which is the lowest thickness, what is it called as a T2? Once you find a T2, then you have to calculate the critical length. Again, it is an important exam question. What is the critical length formula? L is equal to 3.7 square root of d T2. Okay. What is the D? Tank dia in feet. T2, we will always take it in inch. Don't get confused during question. No, this is feet, this is inch. How we can match? That's why this 3.7. Don't get confused. Okay. It is formula is written like this only. Diameter always in feet. Tank height always in feet. But all thicknesses are always in inches. Don't try to equal this. Oh, no, this we have to multiply by. No, don't do this. Now we have to calculate the dT2. Okay. Suppose I am giving you the T2 value. For example, T2 is 0.3 inch. Tank diameter is 150 feet. Calculate. Now what is L? T2 is 0.3 inch. Tank diameter is 150 feet. Calculate what is the D, L, sorry, critical length. So square root of D, what is the tank diameter? 150 into T2.3 m, 0.3 into 3.7. So what is the answer you are getting? Huh? No. You are doing some mistake. Or I am doing some mistake. How you calculate it? What is the answer online, please?
24.8.
Yes, it should be 24.8. First, you have to calculate the within square roots. You have to take square root D and the T2, then you have to multiply by 3.7. So it will be, yeah, you have to first take the square root of 150 multiply by 0.3. Then 3.7 you have to multiply. So answer you will get 24.82. Okay. Now,
This 24.82 is in inch or
inch. The answer is inch. Answer is always in inch. Okay. Now, okay, 24.8 inch. Okay, we'll round it 25 inch. Okay, no, 24 inch only. Okay, 24.8 will take. We cannot round on the higher side. Okay. Now, what is the maximum critical length allowed is 40 inch. Okay. So suppose the answer is coming, say 50 inch. You cannot take 50. If it is coming less than 40, you can take what is the coming 24.8 is the answer. Suppose if it is coming 45, you cannot take 45. You can take only 40. Where this formula is given, I will go part by part. I told you it is a length chapter, so we will get confused. So highlight this one. Page number 4-4. So this is the area, corroded area they marked, and they find the T2. That is the lowest reading. You can see T2, and this is the formula. Calculate the L. 3.7 square root of D2, but not more than 40 inch. It cannot be more than 40 inch.
So 40 மேல இருந்தாலும் 40 தான் எடுத்துக்கணும் சார்.
Yes. The maximum allowed critical length is 40 inch. Is it okay? Now, what is the purpose of this calculating critical length? Question number next. Now we have calculated the critical length 24 point. What is the purpose of this? Now you have to measure the corroded area height. For example, my corroded area height is coming, say 45 inch. But I have to make maximum 24 only. This is the maximum area I can make averaging, thickness averaging. So what is mean by critical length? This is the length you can have for a thickness averaging. You cannot average the entire height. So maximum thickness averaging allowed is only in the critical length. How much you have calculated critical length? 24.8. But here, for example, 45-inch total height of the corroded area. Then you have to make it into two areas. So what is 20? So 45 divided by will come 22.22. So I will make, so say 23. This area 23 inch, this area 23. Suppose this corroded area say is only 20 inch. Then I can make the entire area for thickness averaging. So this critical length is calculated how much area you can average the thickness. Okay, if it is more
Within the 23 inches, we have to take
reading and average it. So this will be a separate area A. This will be separate area. Here only the height is 20 inch. We have only one area. There is no AB. Just I am writing your understanding. Is it clear now? So now here I have only one area I can average, but here you have two areas. Now how we will average the thickness? Suppose I will put lines like this. Now how many lines I have to put it in a area? Minimum 5 lines. This is a closed book question. How many lines I have to put? Minimum 5 vertical lines. You can see the sketch. They have put lines here. A, B, C, D. That is the minimum line. If the width is more, you can put more lines. Now you will ask me the question, what would be the distance between two lines? These are not given in the code. It will be decided by the inspector. இங்க கேட்கலாம் ஒரு லைனுக்கு இன்னொரு லைனுக்கு எவ்வளவு கேப் வைக்கணும்? These are not given in the code. It will be decided by the inspector. But the code says in any small area, minimum 5 lines. Maximum there is no limit. Okay, now how many lines we put here? 1, 2, 3, 4, 5, 6 lines. Now what we will do with this line? Each line I will take thickness reading, multiple reading like this. So each line, how many readings you should take? There is no rule. Again, it will be decided by the inspector. Then each line I will put the average at the bottom. So I will put the vertical line. Say one line I am taking, say 10 readings, all 10 average. Another line, which is the lowest average. Is called T1. So T1 is the lowest average. T2 is the minimum reading in a location. Is it okay now? Lowest average, T1. So each vertical line we have to put a reading and we should have a lowest average. Now, for example, let us okay. So now I have 5 set of readings. So we will evaluate the tank, but we will convert an inch after that. Okay. A tank diameter is 100 feet. Tank height is 56 feet. Course width 8 feet. Specific gravity, these are given. 20 years a patch. So we have A, B, C, D. We have actually, okay, readings in the vertical plane A, B, C, D. So we have taken only 4 readings. Okay, no problem. Generally, what should be minimum number of lines? 5. Okay, no problem. So you have to readings in vertical planes A, B, C, D over length of L. So, okay, now if this is given in millimeter actually. Okay, no problem. What is T2 here? from the reading? What is the T2 here? What is T2? What is the T2 means?
15.5.
Minimum reading in your area. So they have given the readings. Which is the minimum reading in this? Huh? 16.5 is the minimum. 15.25 is the T2. So now I will convert it into inches. How will convert mm to inches? Yeah, mm, it is mm. It is given in mm. Okay, 15.25 divided by 25.4. This is 0.6 inch. So write this, write in your notebook, because we will do the calculation afternoon. T2 is 0.6 inch. Okay, now what is T1? What I told you, T1, we have to average it. So average it now. Yeah, average it. I have given you reading, 4 set of readings. All you have to average A, B, C, D, and which is the lowest average, that is the T1. Again, you average it in millimeter, then convert into, finally you can convert into inches. It is sharing? Okay, yeah. We have many readings. Okay. So average it, then finally we can convert into. I hope you understand how to average it, right? அது அப்படியே இதில் கன்வெர்ட் பண்ணுங்க இன்ச்சில். ரெண்டுமே 0.6 தான் வருதா?
0.69, sir. Correct.
What mm you are getting average?
17, sir.
17 divided by 25.4. 25.4. So 0.669, or we can take it as a 0.67. So you can take it as a 0.67. So for us, T2 is 0.6, T1 is 0.67. எல்லாம் ஒவ்வொன்றும் கிடைக்கணுங்க. A, B, C, D எது லோயஸ்ட் ஆவரேஜோ அதான் வந்து இது. என்ன கொடுத்துருக்காங்க? ஆமா, டிவைடட் பை 5 போட்டிருக்க மாட்டீங்க. எல்லாத்தையும் சேர்த்துட்டீங்களா? அப்படி கிடையாது. ஒவ்வொன்றுக்கும் தனித்தனியா பண்ணும். ஒவ்வொரு லைனுக்கும் ஆவரேஜ் பண்ணும். Okay, so what is that? Now we have T2 of 0.6 inch and a T1 of 0.67 inch. Now where it is given, let us go to the code book, because we'll go, I told you we'll go part by part in the code. Now start from here. Okay. So actual thickness determination, please take 4.3.2 in the code book. For determining the controlling thickness of each shell course, when there are corroded areas of considerable size, measured thickness shall be averaged in accordance with the following procedure. Highlight that one. A, for each area, the authorized inspector shall determine the minimum thickness T2 at any point in the corroded area, excluding the scattered pits. Pits you should not consider it. Okay, next. Calculate the critical length L. L is equal to 3.7 square root of DT2, but not more than 40 inch. This we already completed. That is a closed book question. This one is a closed book question. L is the maximum vertical length in inches when which hoop stresses are assumed to average out The actual length may exceed L. Actual may be more than L. I told you there are, our case, it is more than that. D is the tank diameter in feet. T is the least thickness in inches in the area of corrosion exclusive of feet. Now, the authorized inspector shall visually or otherwise decide which vertical plane in the area likely to be most affected. Profile measurement shall take along each vertical plane for a distance L in the plane to determine the lowest average thickness T1. Lowest average thickness is T1, averaged over length of L using at least 5 equally spaced measurement over length L. So we have to take at least 5 measurements. I told you 5 length. Then, so we know now T1 and T2. Now we have to calculate what is the T required in that area by using the 1 foot formula. But we will not go back to 650. Here the formula is given. See, here there is a 2 formulas. You can see here, page number 4331, page number 4-5. 4-5. The minimum acceptable thickness, we have to find it out. The minimum acceptable thickness continued service shall be determined by one of the more methods. These methods are limited to tank diameter equal to 200 feet. When determining the minimum acceptable thickness, entire shell course. See, you see the sketch. Here it is corroded from the bottom. Here we will use a 1 foot formula, H minus 1. But here it is not corroded from the bottom. Here we will not use a minus 1. H will be taken from this to height. When it is corroding away from the weld, we will not use a minus 1. When you are measuring the entire thickness of the course, we will use a H. Okay. There are, how I know whether it is an entire question, it will be clearly mentioned. So you can see 2 formulas. For determining the minimum acceptable thickness of the entire shell course, T minimum is calculated 2.6 H minus 1 dg divided by SE. No, if it is they are asking entire shell course. Entire shell course, what is the minimum thickness? H minus 1. Only a locally corroded area, H we have to use. When determining the minimum acceptable thickness for any other portion of the shell course, such as locally thinned, 2.6 H dg SE. Now, you know H. What is H? Design liquid level from the corroded area. But the entire shell course means that joint we will take. You can see the H definition. Height from the bottom of the shell course under consideration to the maximum liquid level when evaluating the entire shell course. Suppose the entire shell course is corroded, then we will say from the bottom joint. But height is the L, the lowest. So this is the L. From here we have to take. So here this point only we will take L. Locally thinned area. This is a locally thinned area only I mark. Suppose the entire shell course you want to calculate, you have to use H minus 1.
Away from the well, we have to do it.
Yeah, H minus 1 we will not use. If the question they ask the entire shell course, H minus 1. They asked the locally thinned area, we will use H. What is H? From the corroded area bottom to design liquid level, that they will do. For example, the tank is say 50 feet height, design liquid level. Now it is corroding say 3 feet from the bottom. Then what is the design liquid level? We will say 50 minus 3, 47 from here. We have to take like this. Okay. So,
Sir, sir.
yes. English.
Sir, sorry, sir. Sir, for the given example,
Okay.
should I use H1 as should I use H1 minus 1 formula, or
See, if the question they are asking what is the minimum thickness required for the entire shell course, use H minus 1 formula. Please remember, they will not ask the same question, combine everything. The question will be in the separate question. They will ask either T2 one question, T1 another question, L another question, T minimum another question. They will not club everything. Okay. So if they are asking T minimum, what is the T minimum when the entire shell course? H minus 1. If they are asking locally thinned area, you have to use H, no minus 1. Is it clear? Question you have to read this. Yeah.
so for the given example, we should use only the just H formula. Is that right?
H only we have to use because it is a local area only we mark.
Yeah. Yes, sir.
Okay. Now you know D diameter. You know what is G? Specific gravity. Now E, I already explained you how to calculate. Now how to take the stress. Again, stress we will not follow the 650 table. There is a stress table given here. We have to follow here. Please go to the page number 4-7. Now this is the stress table. Allowable product stress we have to follow. Again, there is a 2 different stress. Lower 2 courses. Lower 2 courses mean first and the second course we have to follow this value. from upper course, you have to follow this code. Okay. Now, if you don't know the material unknown, we have to follow this value. Suppose you don't know the material, we have to follow this. Highlight this, so that is the open book question. Suppose you don't know the tank, because it's in service tank, unknown, you have to follow this one.
Which one we supposed to take? T1 or T2? Which one is greater or less?
No. I'm not yet finished. So I am just explaining, because I told you it is this particular area is not arranged correctly in the code. They put here and there. So that's why I'm going in a easy understanding sequence. Then we will do, because how to evaluate T1 and T2, they is given on the first, how to evaluate T1, then how to calculate T1, T2, they are given later. That is not a big. Okay. Is it clear so far? Okay, I will stop here. 2
Please,
o'clock
can
we
you
will
repeat
continue.
exactly
Yes,
for?
please.
Yeah, can you repeat please for H and H minus 1?
Yeah, see.
What time
if
we
you are-
select exactly?
Yeah, this is suppose the entire, for example, the entire shell is corroded.
Okay.
Then you have to use a H minus 1 formula.
Uh,
If you are only locally thin the area corroded like this or here, then we will use a H formula. How I know locally thin the area? It will be mentioned in the question. The question asks, what is the T minimum when the entire shell course is corroded? We have to use H minus 1. If they are asking there is a locally thinned area in the second shell course or first shell course, there we should not use H minus 1. We will use H only. Okay.
Up to 40 inches.
If it is up to 40 inches critical length, we will take the actual value 20, 25. But if this critical length called crossing 40 inches, we have to take only 40 as the reading. That's all. 40 is the maximum critical length allowed by the 653 code. Okay, so we will do the calculation afternoon, how to calculate the T minimum. Okay, I will give you values. So 2 o'clock we will continue the class. Thank you. Chapter konja navaru, matha chapter la